Every day, millions of people use butter without ever thinking about how it's made. But the process behind this kitchen staple is incredible. Inside massive factories, fresh cream is transformed into rich, golden butter through a high-speed and precision-driven process. In this documentary, we'll take you behind the scenes to uncover the fascinating journey from dairy farm to factory, where advanced machinery churns and packages butter on an industrial scale. Get ready to witness the craftsmanship behind one of the world's most essential ingredients. The process of butter production in a factory begins with the acquisition of raw cream, which is typically sourced from dairy farms. The cream must meet strict quality standards to ensure it is suitable for butter production. Upon arrival at the factory, the cream undergoes comprehensive testing to verify its fat content, microbial levels, and overall purity. This initial assessment ensures that only the highest quality cream enters the production line. Once approved, the cream is stored in large refrigerated tanks, where it is maintained at a precise temperature to preserve its freshness until processing begins. Standardization is the next critical step in butter production. This involves adjusting the fat content of the cream to a consistent level, usually around 40%, which is optimal for churning into butter. Advanced machinery is employed to blend cream with varying fat contents or to add skim milk as needed. This precise adjustment ensures uniformity in the final product. Standardization also allows factories to produce different types of butter, such as light or extra rich varieties, by altering the fat percentage accordingly. The standardized cream is then pasteurized to eliminate any harmful bacteria and to enhance shelf stability. Pasteurization involves heating the cream to a specific temperature for a set duration, followed by rapid cooling to prevent spoilage. After pasteurization, the cream enters the aging phase. This step is crucial for developing the desired texture and flavor profile of the butter. During aging, the cream is stored at a controlled temperature for several hours, allowing natural enzymes and lactic acid bacteria to work on the fat molecules. For cultured butter production, additional bacterial cultures are introduced during this stage to impart a richer, more complex flavor. The aging process can vary depending on the type of butter being produced, with some recipes requiring longer periods to achieve the desired characteristics. Once the cream has been adequately aged, it moves to the churning stage. In industrial settings, large-scale churns are used to efficiently process vast quantities of cream. The churning process separates the butterfat from the buttermilk through continuous agitation. As the cream is churned, the fat globules begin to coalesce, forming small grains of butter. These grains gradually grow larger as the churning continues, eventually forming a cohesive mass of butter. The buttermilk, which is the liquid component remaining after the fat solids have separated, is drained off and often used in other food products, such as baking ingredients or animal feed. Following churning, the butter mass undergoes washing to remove any residual buttermilk and impurities. Cold water is carefully sprayed over the butter while it is continuously agitated to ensure thorough cleaning. This step is vital for improving the texture and extending the shelf life of the butter. After washing, the butter is worked to achieve the desired consistency. If salted butter is being produced, salt is added at this stage to act as a preservative and enhance flavor. The amount of salt varies based on the specific product requirements and regional preferences. The working process involves kneading the butter to distribute the salt evenly and to expel any remaining water. The packaging phase is the next significant step in butter production. At this point, the butter is shaped into blocks, tubs, or sticks, depending on the intended market. Modern factories utilize automated equipment to shape and package the butter efficiently. Each piece is weighed precisely to ensure accurate portioning. Packaging materials are selected for their ability to protect the butter from environmental factors such as light, air, and moisture, which can degrade its quality. Common packaging options include foil-wrapped blocks, plastic tubs, and stick wrappers. The design of the packaging often incorporates branding elements and nutritional information to appeal to consumers. Throughout the entire production process, quality control measures are rigorously enforced to maintain the integrity of the butter. Multiple checks and tests are conducted at various stages to ensure compliance with safety and quality standards. Microbiological testing confirms the absence of harmful bacteria, while physical tests assess the texture and spreadability of the butter. Chemical analysis verifies the fat content and flavor profiles. Sensory evaluation panels may also assess the taste, aroma, and appearance of the butter to ensure it meets consumer expectations. Any batch that fails to meet these criteria is either reprocessed or discarded to uphold product quality. Factories implementing sustainable practices aim to minimize their environmental impact. Waste materials, such as the buttermilk separated during churning, can be further processed to create valuable byproducts like whey protein. Energy usage is optimized through the recovery of waste heat generated during thermal processes, such as pasteurization, which can be reused within the factory. Water used in washing and cleaning operations is treated before discharge to comply with environmental regulations. These efforts contribute to a more sustainable and eco-friendly production process. Technological advancements have significantly enhanced the efficiency and precision of butter production in factories. Computer-controlled systems monitor and adjust parameters such as temperature, speed, and timing during each stage of the process. Robotics and artificial intelligence are increasingly integrated into factory operations to improve accuracy and reduce human error. For example, automated sensors can detect inconsistencies in the cream's fat content during standardization and make real-time adjustments to correct them. These innovations not only streamline the production process, but also allow for greater customization and flexibility in meeting diverse market demands. Consumer trends play a pivotal role in shaping butter production strategies. With growing interest in health-conscious eating, there is an increasing demand for low-fat or plant-based alternatives. Factories respond by developing new recipes and production methods to cater to these emerging preferences. Transparency in sourcing and production practices is becoming increasingly important to consumers, leading factories to adopt traceability systems that provide detailed information about the origin and journey of their products. This builds trust and enhances brand loyalty among customers. The global market for butter is influenced by a variety of factors, including dietary habits, cultural preferences, and economic conditions. Factories must remain adaptable and responsive to these changes to stay competitive. They invest in research and development to innovate and improve their products continuously. Collaboration with suppliers, retailers, and consumers helps factories understand market needs and align their production strategies accordingly. By leveraging technology, adhering to quality standards, and embracing sustainable practices, butter factories aim to deliver superior products that meet and exceed customer expectations. In the context of industrial butter production, the procurement of raw cream is a meticulous process. Cream is sourced from dairy farms that adhere to stringent quality protocols. Upon arrival at the factory, the cream is tested for fat content, microbial levels, and overall purity. Approved cream is stored in refrigerated tanks at a precise temperature to maintain freshness. Standardization adjusts the fat content to approximately 40%, using advanced machinery to blend cream with varying fat contents or add skim milk as necessary. This step ensures uniformity in the final product and enables the production of different butter varieties by altering the fat percentage. Pasteurization follows standardization, involving heating the cream to a specific temperature for a set duration to eliminate harmful bacteria and enhance shelf stability. After pasteurization, the cream enters the aging phase, where it is stored at a controlled temperature for several hours to develop the desired texture and flavor. Cultured butter production introduces additional bacterial cultures during this stage to impart a richer flavor. Churning separates the butterfat from the buttermilk through continuous agitation, forming small grains of butter that grow larger as the process continues. the buttermilk is drained off and often utilized in other food products. Washing removes residual buttermilk and impurities from the butter mass using cold water while it is continuously agitated. Salt is added during the working process if producing salted butter, enhancing flavor and acting as a preservative. Automated equipment shapes and packages the butter into blocks, tubs, or sticks with precise weighing, ensuring accurate portioning. Packaging materials protect the butter from environmental factors, incorporating branding elements and nutritional information to appeal to consumers. Quality control measures are enforced throughout the production process, with multiple checks and tests ensuring compliance with safety and quality standards. Microbiological testing confirms the absence of harmful bacteria. Physical tests assess texture and spreadability, and chemical analysis verifies fat content and flavor profiles. Sensory evaluation panels assess taste, aroma, and appearance to meet consumer expectations. Sustainable practices minimize environmental impact, recycling waste materials, optimizing energy usage, and treating water before discharge. Technological advancements enhance efficiency and precision with computer-controlled systems, monitoring and adjusting parameters during production. Consumer trends shape production strategies, driving innovation in recipes and methods to meet health-conscious demands and build transparency through traceability systems. Collaboration with stakeholders helps factories understand market needs and align production strategies accordingly, delivering superior products that exceed customer expectations. Industrial butter production involves intricate steps and considerations, balancing tradition with innovation. From cream preparation to final packaging, every stage is meticulously controlled to ensure high-quality butter. Advanced technologies, adherence to quality standards, and sustainability initiatives enhance efficiency and reduce environmental impact. Adapting to consumer trends ensures relevance in a competitive market, demonstrating the industry's commitment to responsible and forward-thinking practices. Butter production in factories combines art and science, transforming simple cream into a beloved staple enjoyed worldwide. The journey of butter from cream to table showcases the complexity and sophistication involved in industrial-scale production. Precise control over every stage, rigorous quality assurance, and integration of modern technologies highlight the dedication to delivering a versatile and delicious product. This exploration reveals the detailed processes and considerations that define butter production in a factory setting. Cream acquisition begins with sourcing from dairy farms, adhering to quality protocols. Testing ensures fat content, microbial levels, and purity meet standards. Approved cream is stored in refrigerated tanks at controlled temperatures. Standardization adjusts fat content to 40% using advanced machinery, enabling uniformity and variety production. Pasteurization eliminates bacteria and enhances shelf stability through precise heating and cooling. Aging develops texture and flavor, with cultured butter benefiting from additional bacterial cultures. Churning separates butterfat from buttermilk, forming grains that grow larger during continuous agitation. Buttermilk is drained off for reuse in other food products. Washing removes impurities using cold water while agitating the butter mass. Salt is added during the working process for flavor enhancement and preservation. Automated equipment shapes and packages butter into blocks, tubs, or sticks, with precise weighing ensuring accurate portions. Packaging materials protect against environmental factors, incorporating branding and nutritional information. Quality control enforces safety and quality standards through microbiological testing, physical assessments, and chemical analyses. Sensory evaluations ensure taste, aroma, and appearance meet expectations. Sustainable practices minimize environmental impact by recycling waste, optimizing energy use, and treating water before discharge. Technological advancements enhance efficiency and precision, with computer-controlled systems monitoring production parameters. Consumer trends drive innovation in recipes and methods, promoting health-conscious alternatives and transparency through traceability systems. Collaboration with stakeholders aligns production strategies with market needs, delivering superior products exceeding customer expectations. The creation of mayonnaise in a factory is an intricate process that combines the precision of science with the artistry of culinary expertise. At its essence, mayonnaise is an emulsion, a delicate blend of oil, water, and egg yolks, stabilized by natural emulsifiers such as lecithin. This journey from raw ingredients to jarred condiment involves numerous steps, each meticulously controlled to ensure consistency, flavor, and safety. It all begins with the procurement of high-quality raw materials. Eggs, vegetable oil, vinegar, and various seasonings form the foundation of mayonnaise production. Eggs, particularly their yolks, are crucial because they contain lecithin, a natural emulsifier that binds oil and water together. These eggs must meet stringent standards for freshness and cleanliness before entering the facility. Similarly, the choice of oil is critical. It must be pure and flavorful, as it significantly influences the taste of the final product. Vinegar serves dual purposes, acting as both a preservative and a flavor enhancer. Additional seasonings like salt, sugar, mustard powder, or garlic extract may also be added depending on the desired variety. Once these ingredients arrive at the factory, they undergo rigorous testing to ensure compliance with quality specifications. Microbial contamination, pH levels, and chemical composition are carefully checked. Approved ingredients are then stored in large tanks or silos under controlled conditions to preserve their integrity until needed. Eggs are often pasteurized at this stage to eliminate any potential pathogens, ensuring the safety of the final product. The heart of mayonnaise production lies in the mixing process, where individual components are transformed into a smooth, creamy emulsion. Initially, egg yolks are blended with vinegar and seasonings in a specialized mixer. This mixture acts as the base, providing the foundation for the emulsion. As the blending continues, liquid vegetable oil is slowly introduced into the mix. The key here is gradual addition. Pouring the oil too quickly can destabilize the emulsion, leading to separation. Advanced machinery, equipped with precise flow control mechanisms, ensures that the oil is incorporated at just the right rate, maintaining stability throughout the process. During this phase, the mechanical action of the mixer helps break down the oil into microscopic droplets, dispersing them evenly within the aqueous phase. Lecithin present in the egg yolks plays a pivotal role here, acting as a bridge between the oil and water molecules to prevent them from separating. This step requires careful monitoring of temperature and speed to achieve optimal results. Too much heat can denature the proteins in the egg yolks, compromising the emulsion, while insufficient agitation might leave the mixture lumpy or inconsistent. Once the initial emulsion has been formed, further adjustments may be made to fine-tune the texture and flavor. Additional ingredients, such as stabilizers or thickeners, may be added to enhance the viscosity of the mayonnaise, ensuring it maintains its creamy consistency over time. Some manufacturers also incorporate antioxidants to extend shelf life and preserve freshness. These additions are done using automated systems that measure quantities with remarkable accuracy, guaranteeing uniformity across batches. After the mixing process is complete, the mayonnaise moves to the homogenization stage. Homogenization involves subjecting the mixture to intense pressure through narrow channels, breaking down any remaining large oil droplets into even smaller particles. This step not only improves the stability of the emulsion, but also enhances the smoothness and silkiness of the final product. Modern factories capable of processing vast quantities of mayonnaise efficiently while maintaining consistent quality. Next comes the pasteurization phase, a critical step in ensuring the safety of the mayonnaise. Although the eggs have already been pasteurized earlier in the process, the entire mixture is heated to a specific temperature for a set period to eliminate any residual bacteria or microorganisms. Pasteurization also helps stabilize the flavors, allowing them to meld together harmoniously. After heating, the mayonnaise is rapidly cooled to prevent degradation of its texture or nutritional value. With the mayonnaise now fully prepared, it proceeds to the packaging stage. Here, advanced filling machines dispense precise amounts of the product into jars, bottles, or sachets, depending on the intended market. Packaging materials are chosen for their ability to protect the mayonnaise from light, air, and moisture, which could otherwise compromise its quality. For instance, opaque plastic containers or glass jars with tight-fitting lids are commonly used to shield the contents from external factors. Each package is sealed hermetically to ensure freshness until it reaches the consumer. Quality assurance is woven seamlessly into every aspect of mayonnaise production. Throughout the process, samples are regularly taken and analyzed to verify that the product meets all required standards. Microbiological tests confirm the absence of harmful bacteria, while sensory evaluations assess factors such as color, aroma, and taste. Physical properties such as viscosity and spreadability are also measured to ensure the mayonnaise performs well when used in culinary applications. Any deviations from established norms trigger immediate corrective actions, ensuring that only the highest quality mayonnaise leaves the factory. In addition to producing standard mayonnaise, many factories specialize in creating variations tailored to specific tastes and dietary preferences. Reduced fat versions substitute some of the oil with water or other ingredients to lower calorie content without sacrificing flavor. Low sodium options cater to health-conscious consumers, while organic or vegan alternatives appeal to those seeking more sustainable or plant-based choices. These specialty products require unique formulations and production techniques, showcasing the adaptability of modern manufacturing facilities. Sustainability plays a significant role in contemporary mayonnaise production. Factories increasingly focus on minimizing waste, conserving energy, and reducing environmental impact. Waste oils generated during production are recycled into biofuels or other useful byproducts, while water used in cleaning processes is treated before discharge to comply with ecological regulations. Energy-efficient equipment and renewable energy sources further contribute to greener operations. Moreover, sourcing ingredients responsibly, such as using cage-free eggs or sustainably harvested oils, aligns with growing consumer demand for ethically produced goods. Technological advancements continue to revolutionize the mayonnaise industry. Automation streamlines production lines, enabling faster throughput while maintaining exceptional quality. Artificial intelligence and machine learning algorithms optimize processes by predicting equipment maintenance needs, identifying inefficiencies, and suggesting improvements. Robotics handle repetitive tasks with unmatched precision, freeing human workers to focus on higher value activities. These innovations not only boost productivity, but also allow factories to respond swiftly to changing market demands. Consumer trends heavily influence the evolution of mayonnaise production. With increasing awareness about nutrition and wellness, there is a growing interest in healthier alternatives and transparent labeling. Manufacturers address these concerns by developing innovative recipes and providing detailed information about ingredient origins and production methods. Customization capabilities enable factories to produce niche products catering to regional preferences or emerging dietary fads, such as keto-friendly or gluten-free mayonnaises. Global trade dynamics also shape the way mayonnaise is manufactured. Export markets demand adherence to diverse regulatory frameworks, requiring factories to implement flexible systems capable of meeting varying international standards. Collaboration with suppliers, distributors, and retailers ensures alignment with global supply chains, facilitating timely delivery of products worldwide. Continuous investment in research and development keeps factories at the forefront of technological innovation, ensuring their competitiveness in an ever-evolving marketplace. Beyond the technical aspects of production, the cultural significance of mayonnaise cannot be overlooked. In many regions, it is more than just a condiment. It is a symbol of culinary tradition and innovation. From classic sandwiches to elaborate dressings, mayonnaise serves as a versatile ingredient that enhances countless dishes. Its widespread popularity has driven manufacturers to explore new flavors and textures, expanding its appeal beyond traditional boundaries. For example, flavored varieties infused with herbs, spices, or even fruit extracts offer exciting options for adventurous cooks and diners alike. Factories also prioritize food safety above all else, implementing comprehensive protocols to mitigate risks at every stage of production. Hazard analysis and critical control points. Systems identify potential hazards and establish measures to prevent them. Regular audits and certifications ensure compliance with local and international regulations. Employee training programs emphasize hygiene practices and proper handling procedures, reinforcing a culture of safety throughout the organization. Packaging design plays a vital role in the marketing and distribution of mayonnaise. Modern factories invest heavily in developing attractive and functional packaging solutions that appeal to consumers while protecting the product. Innovations in material science have led to the creation of lightweight yet durable containers that reduce shipping costs and environmental impact. Resealable caps and squeezable bottles enhance user convenience, making it easier for customers to enjoy the product without compromising freshness. Supply chain management is another critical component of successful mayonnaise production. Efficient logistics ensure a steady flow of raw materials into the factory and finished goods out to retailers. Strategic partnerships with suppliers help secure reliable sources of high-quality ingredients, while relationships with distributors facilitate rapid delivery to diverse markets. Real-time data analytics enable factories to forecast demand accurately, optimizing inventory levels and reducing waste. Research and development remain central to the growth of the mayonnaise industry. Scientists and engineers continuously experiment with new formulations, processing techniques, and packaging technologies to improve product quality and sustainability. Emerging trends in biotechnology and fermentation offer promising avenues for enhancing flavor profiles and extending shelf life. Collaborations with academic institutions and research organizations provide valuable insights into cutting-edge developments that can be applied to commercial production. The economic impact of mayonnaise production extends far beyond the factory floor. It supports jobs in agriculture, transportation, retail, and related industries, contributing significantly to local and national economies. By investing in community initiatives and sustainable practices, manufacturers demonstrate their commitment to corporate responsibility and long-term viability. Programs aimed at reducing carbon footprints, conserving water, and promoting biodiversity align with broader societal goals of environmental stewardship. As consumer preferences evolve, so too does the nature of mayonnaise production. Health-conscious individuals seek products with fewer additives and artificial ingredients, driving manufacturers to adopt cleaner label approaches. Clear communication about ingredient sourcing and production methods builds trust and fosters loyalty among discerning customers. Educational campaigns highlighting the benefits of mayonnaise as part of a balanced diet further reinforce its position as a staple in kitchens worldwide. Finally, the future of mayonnaise production promises exciting possibilities. Advances in automation, digitalization, and artificial intelligence will likely transform traditional manufacturing processes, enabling greater efficiency and flexibility. Personalized nutrition platforms may one day allow consumers to customize their own mayonnaise blends based on individual dietary needs and preferences. Meanwhile, ongoing efforts to reduce environmental impact and promote social responsibility will ensure that mayonnaise remains a beloved and sustainable choice for generations to come. Through precise control of every stage, from ingredient preparation to final packaging, factories ensure that each jar of mayonnaise delivers consistent quality and satisfaction. This exploration reveals the depth and complexity behind the seemingly straightforward process of making mayonnaise, highlighting the dedication and expertise required to bring this indispensable condiment to tables everywhere. The production of olive oil in a factory is a meticulous process that combines ancient traditions with modern technology to create one of the world's most revered culinary staples. Olive oil, often referred to as liquid gold, has been cherished for millennia for its rich flavor, health benefits, and versatility in cooking. The journey from olive groves to bottling lines involves several intricate steps, each designed to preserve the natural qualities of the olives while ensuring consistency and quality. It all begins with the cultivation of olives, which are grown primarily in regions with Mediterranean climates such as Spain, Italy, Greece, and parts of North Africa. The choice of olive variety plays a significant role in determining the flavor profile of the final product. Different varieties produce oils with distinct characteristics. Some are fruity and mild, while others are robust and peppery. Harvesting typically occurs between late autumn and early winter when the olives reach their peak ripeness. Timing is crucial because underripe olives yield less oil, while overripe ones can lead to off flavors. Once harvested, the olives are transported to the factory where they undergo rigorous quality checks. These inspections ensure that only healthy, undamaged fruits are used in production. Any leaves, stems, or debris are removed during this stage to prevent contamination. The cleaned olives are then stored temporarily in ventilated containers to maintain freshness until processing begins. The first step in the factory is washing the olives. This process removes dirt, dust, and any remaining impurities from the surface of the fruit. Clean water is sprayed over the olives while they are gently agitated to ensure thorough rinsing. After washing, the olives proceed to the milling stage, where they are crushed into a paste. Traditionally, stone mills were used for this purpose, but modern factories employ stainless steel crushers or hammer mills for greater efficiency. The goal is to break down the cell walls of the olives, releasing the oil trapped inside. Following milling, the olive paste moves to the malaxation phase. Malaxation involves slowly stirring the paste at a controlled temperature to allow small droplets of oil to coalesce into larger ones. This step is critical because it enhances the extraction rate and improves the quality of the oil by promoting better separation of solids and liquids. The duration of malaxation varies depending on factors such as olive variety and desired flavor profile, but it typically lasts between 20 and 40 minutes. After malaxation, the next step is decantation, where the olive paste is separated into its three main components: oil, water, and solid residue known as pomace. In traditional methods, this was achieved using centrifuges or pressing systems. Modern factories predominantly use horizontal decanter centrifuges, which spin the paste at high speeds to separate the heavier solid particles from the lighter liquid phases. The resulting mixture of oil and water is further refined in a second stage centrifuge, which separates the oil completely from any remaining water or fine particles. At this point, the crude olive oil undergoes additional treatments to refine its quality. Filtration is often employed to remove any residual suspended solids, producing a clearer and more stable product. Some manufacturers also implement cold filtration techniques to preserve the natural flavors and aromas of the oil. For extra virgin olive oil, minimal processing is preferred to retain its superior taste and nutritional value. However, lower grade oils may be subjected to chemical refining processes to improve clarity, color, and shelf life. Storage is another critical aspect of olive oil production. Once extracted, the oil is transferred to large stainless steel tanks where it is kept at controlled temperatures to prevent oxidation and degradation. These tanks are equipped with inert gas systems to displace oxygen, further protecting the oil's quality. During storage, the oil continues to settle, allowing any remaining microscopic particles to sink to the bottom of the tank. Periodic sampling and analysis ensure that the oil maintains its desired characteristics throughout this period. Packaging represents the final stage of the production process. Olive oil is bottled in various sizes and formats, ranging from small glass bottles to bulk plastic containers, depending on the target market. Packaging materials are chosen for their ability to shield the oil from light, air, and moisture, which can negatively affect its quality. Dark-colored glass or opaque plastic bottles are commonly used to protect against UV exposure, while tight-fitting caps ensure an airtight seal. Labels provide important information about the oil's origin, grade, and nutritional content, helping consumers make informed purchasing decisions. Quality control is woven into every aspect of olive oil production. Throughout the process, samples are regularly taken and analyzed to verify compliance with strict international standards. Sensory evaluations assess factors such as aroma, taste, and mouthfeel, ensuring the oil meets expectations for its designated grade. Chemical analyses measure parameters like acidity levels, peroxide values, and fatty acid composition to confirm purity and authenticity. Any deviations from established norms trigger immediate corrective actions, guaranteeing that only the highest quality olive oil reaches the market. In addition to producing standard olive oil, many factories specialize in creating premium varieties tailored to specific tastes and dietary preferences. Extra virgin olive oil, considered the finest grade, is produced using mechanical means only, without heat or chemicals, to preserve its natural flavors and antioxidants. Virgin olive oil undergoes slightly more processing, but still retains much of its original character. Refined olive oil, on the other hand, is treated with chemical agents to neutralize defects and achieve uniformity in taste and appearance. Specialty oils infused with herbs, spices, or citrus extracts offer unique flavor profiles that appeal to adventurous cooks and diners alike. Sustainability is increasingly becoming a priority in olive oil production. Factories adopt eco-friendly practices to minimize waste, conserve resources, and reduce environmental impact. Pomace, the solid residue left after extraction, is often recycled into biofuels or animal feed, reducing landfill contributions. Water used in cleaning processes is treated before discharge to comply with ecological regulations. Energy-efficient equipment and renewable energy sources further contribute to greener operations. Moreover, sourcing olives responsibly, such as supporting local farmers who practice sustainable agriculture, aligns with growing consumer demand for ethically produced goods. Technological advancements continue to revolutionize the olive oil industry. Automation streamlines production lines, enabling faster throughput while maintaining exceptional quality. Artificial intelligence and machine learning algorithms optimize processes by predicting equipment maintenance needs, identifying inefficiencies, and suggesting improvements. Robotics handle repetitive tasks with unmatched precision, freeing human workers to focus on higher value activities. These innovations not only boost productivity, but also allow factories to respond swiftly to changing market demands. Consumer trends heavily influence the evolution of olive oil production. With increasing awareness about nutrition and wellness, there is a growing interest in healthier alternatives and transparent labeling. Manufacturers address these concerns by developing innovative formulations and providing detailed information about ingredient origins and production methods. Customization capabilities enable factories to produce niche products catering to regional preferences or emerging dietary fads, such as organic or keto-friendly options. Global trade dynamics also shape the way olive oil is manufactured. Export markets demand adherence to diverse regulatory frameworks, requiring factories to implement flexible systems capable of meeting varying international standards. Collaboration with suppliers, distributors, and retailers ensures alignment with global supply chains, facilitating timely delivery of products worldwide. Continuous investment in research and development keeps factories at the forefront of technological innovation, ensuring their competitiveness in an ever-evolving marketplace. Beyond the technical aspects of production, the cultural significance of olive oil cannot be overlooked. In many regions, it is more than just a cooking ingredient. It is a symbol of heritage and tradition. From drizzling it over fresh bread to using it as the base for elaborate sauces, olive oil serves as a versatile foundation for countless dishes. Its widespread popularity has driven manufacturers to explore new applications and presentations, expanding its appeal beyond traditional boundaries. Factories also prioritize food safety above all else, implementing comprehensive protocols to mitigate risks at every stage of production. Hazard analysis and critical control. Point systems identify potential hazards and establish measures to prevent them. Regular audits and certifications ensure compliance with local and international regulations. Employees emphasize hygiene practices and proper handling procedures, reinforcing a culture of safety throughout the organization. Packaging design plays a vital role in the marketing and distribution of olive oil. Modern factories invest heavily in developing attractive and functional packaging solutions that appeal to consumers while protecting the product. Innovations in material science have led to the creation of lightweight yet durable containers that reduce shipping costs and environmental impact. Resealable caps and pour spouts enhance user convenience, making it easier for customers to enjoy the product without compromising freshness. Supply chain management is another critical component of successful olive oil production. Efficient logistics ensure a steady flow of raw materials into the factory and finished goods out to retailers. Strategic partnerships with suppliers help secure reliable sources of high-quality olives, while relationships with distributors facilitate rapid delivery to diverse markets. Real-time data analytics enable factories to forecast demand accurately, optimizing inventory levels and reducing waste. Research and development remain central to the growth of the olive oil industry. Scientists and engineers continuously experiment with new formulations, processing techniques, and packaging technologies to improve product quality and sustainability. Emerging trends in biotechnology and fermentation offer promising avenues for enhancing flavor profiles and extending shelf life. Collaborations with academic institutions and research organizations provide valuable insights into cutting-edge developments that can be applied to commercial production. The economic impact of olive oil production extends far beyond the factory floor. It supports jobs in agriculture, transportation, retail, and related industries, contributing significantly to local and national economies. By investing in community initiatives and sustainable practices, manufacturers demonstrate their commitment to corporate responsibility and long-term viability. Programs aimed at reducing carbon footprints, conserving water, and promoting biodiversity align with broader societal goals of environmental stewardship. As consumer preferences evolve, so too does the nature of olive oil production. Health-conscious individuals seek products with fewer additives and artificial ingredients, driving manufacturers to adopt cleaner label approaches. Clear communication about ingredient sourcing and production methods builds trust and fosters loyalty among discerning customers. Educational campaigns highlighting the benefits of olive oil as part of a balanced diet further reinforce its position as a staple in kitchens worldwide. Finally, the future of olive oil production promises exciting possibilities. Advances in automation, digitalization, and artificial intelligence will likely transform traditional manufacturing processes, enabling greater efficiency and flexibility. Personalized nutrition platforms may one day allow consumers to customize their own olive oil blends based on individual dietary needs and preferences. Meanwhile, ongoing efforts to reduce environmental impact and promote social responsibility will ensure that olive oil remains a beloved and sustainable choice for generations to come. Through precise control of every stage, from olive cultivation to final packaging, factories ensure that each bottle of olive oil delivers consistent quality and satisfaction. This exploration reveals the depth and complexity behind the seemingly straightforward process of making olive oil, highlighting the dedication and expertise required to bring this indispensable liquid to tables everywhere. The production of whipped cream in a factory is a highly refined process that combines traditional techniques with modern technology to create one of the most beloved and versatile dairy products. Whipped cream, known for its light, airy texture and rich flavor, has become an essential ingredient in desserts, beverages, and culinary creations worldwide. The journey from raw materials to finished product involves several intricate steps, each meticulously controlled to ensure consistency, quality, and safety. It all begins with the procurement of high-quality cream, which serves as the foundation of whipped cream production. Cream is typically sourced from fresh milk, separated through centrifugation or other mechanical processes to concentrate the fat content. For whipped cream, cream with a fat content of around 35% is ideal, as it provides the necessary structure and stability when aerated. The cream must meet stringent quality standards, including checks for purity, fat content, and microbial levels before entering the factory. Once approved, the cream is stored in refrigerated tanks at a precise temperature to preserve its freshness until processing begins. Upon arrival at the factory, the cream undergoes rigorous testing to ensure it meets the required specifications. This includes microbiological testing to confirm the absence of harmful bacteria, chemical analysis to verify fat content, and sensory evaluations to assess flavor and aroma. Approved cream is then standardized to ensure uniformity across batches. Standardization involves adjusting the fat content to the desired level using advanced machinery that blends cream with varying fat contents or adds skim milk as needed. This step is critical for maintaining consistent product quality and enabling customization for different varieties of whipped cream. After standardization, the cream moves to the pasteurization stage. Pasteurization is a crucial step in ensuring the safety and shelf life of the whipped cream. During this process, the cream is heated to a specific temperature for a set duration, followed by rapid cooling. This eliminates any harmful microorganisms while preserving the cream's natural flavors and nutritional properties. Pasteurized cream is then stored at a controlled temperature to maintain its quality until further processing. The next phase in whipped cream production is stabilization. To enhance the cream's ability to hold air and maintain its fluffy texture, stabilizers such as guar gum, carrageenan, or xanthan gum may be added. These ingredients help prevent separation and improve the cream's whipping properties. Emulsifiers like mono and diglycerides may also be incorporated to ensure smooth blending and even distribution of fat globules during aeration. The choice of stabilizers and emulsifiers depends on the desired characteristics of the final product and regulatory requirements in different markets. Once stabilized, the cream proceeds to the whipping stage, where it is transformed into its characteristic light and airy form. In industrial settings, this is achieved using large-scale whipping machines capable of processing vast quantities of cream efficiently. The whipping process involves introducing air into the cream while agitating it at a controlled speed and temperature. As the cream is whipped, the fat globules coalesce, forming a network that traps air bubbles, creating the signature texture of whipped cream. The degree of aeration is carefully monitored to achieve the desired density and volume. During whipping, additional ingredients such as sugar, vanilla extract, or other flavorings may be incorporated to enhance the taste and appeal of the whipped cream. Sugar not only sweetens the product, but also helps stabilize the foam by increasing viscosity and improving bubble formation. Flavorings are carefully selected and measured to ensure they complement the natural richness of the cream without overpowering it. Some manufacturers produce flavored variations, such as chocolate, coffee, or fruit-infused whipped creams, catering to diverse consumer preferences. After whipping, the cream is cooled to stabilize its structure and prevent degradation. Cooling is typically done in a controlled environment to ensure the whipped cream retains its shape and texture. At this stage, the product may undergo further adjustments to fine-tune its consistency and appearance. Advanced machinery is used to measure parameters such as overrun and firmness, ensuring the whipped cream meets the desired specifications. Packaging represents the final stage of whipped cream production. Modern factories utilize automated equipment to dispense precise amounts of the product into various formats, including aerosol cans, plastic tubs, or flexible pouches. Aerosol packaging is particularly popular due to its convenience and ease of use, allowing consumers to spray the whipped cream directly onto their favorite foods. Nitrous oxide is often used as the propellant in aerosol cans, providing both the means of dispensing and contributing to the cream's light texture. Packaging materials are chosen for their ability to protect the whipped cream from light, air, and moisture, which can affect its quality. Labels provide important information about the product's ingredients, nutritional content, and usage instructions, helping consumers make informed choices. Quality control is an integral part of whipped cream production, implemented throughout every stage of the process. Samples are regularly taken and analyzed to verify compliance with strict microbiological tests confirm the absence of harmful bacteria, while physical and chemical analyses assess factors such as overrun, firmness, and fat content. Sensory evaluations evaluate the whipped cream's flavor, aroma, and texture to ensure it meets consumer expectations. Any deviations from established norms trigger immediate corrective actions, guaranteeing that only the highest quality whipped cream reaches the market. In addition to producing standard whipped cream, many factories specialize in creating premium varieties tailored to specific tastes and dietary preferences. Low-fat or non-dairy alternatives cater to health-conscious consumers, while organic options appeal to those seeking more sustainable choices. Specialty flavors and textures offer exciting options for adventurous cooks and diners alike. These variations require unique formulations and production techniques, showcasing the adaptability of modern manufacturing facilities. Sustainability plays a significant role in contemporary whipped cream production. Factories increasingly focus on minimizing waste, conserving resources, and reducing environmental impact. Waste cream generated during production is recycled into animal feed or biofuels, while water used in cleaning processes is treated before discharge to comply with ecological regulations. Energy-efficient equipment and renewable energy sources further contribute to greener operations. Moreover, sourcing cream responsibly, such as supporting local farmers who practice sustainable agriculture, aligns with growing consumer demand for ethically produced goods. Technological advancements continue to revolutionize the whipped cream industry. Automation streamlines production lines, enabling faster throughput while maintaining exceptional quality. Artificial intelligence and machine learning algorithms optimize processes by predicting equipment maintenance needs, identifying inefficiencies, and suggesting improvements. Robotics handle repetitive tasks with unmatched precision, freeing human workers to focus on higher value activities. These innovations not only boost productivity, but also allow factories to respond swiftly to changing market demands. Consumer trends heavily influence the evolution of whipped cream production. With increasing awareness about nutrition and wellness, there is a growing interest in healthier alternatives and transparent labeling. Manufacturers address these concerns by developing innovative formulations and providing detailed information about ingredient origins and production methods. Customization capabilities enable factories to produce niche products catering to regional preferences or emerging dietary fads, such as keto-friendly or gluten-free options. Global trade dynamics also shape the way whipped cream is manufactured. Export markets demand adherence to diverse regulatory frameworks, requiring factories to implement flexible systems capable of meeting varying international standards. Collaboration with suppliers, distributors, and retailers ensures alignment with global supply chains, facilitating timely delivery of products worldwide. Continuous investment in research and development keeps factories at the forefront of technological innovation, ensuring their competitiveness in an ever-evolving marketplace. Beyond the technical aspects of production, the cultural significance of whipped cream cannot be overlooked. In many regions, it is more than just a topping. It is a symbol of indulgence and celebration. From birthday cakes to holiday feasts, whipped cream serves as a versatile ingredient that enhances countless dishes. Its widespread popularity has driven manufacturers to explore new applications and presentations, expanding its appeal beyond traditional boundaries. Factories also prioritize food safety above all else, implementing comprehensive protocols to mitigate risks at every stage of production. Hazard analysis and critical control. Point systems identify potential hazards and establish measures to prevent them. Regular audits and certifications ensure compliance with local and international regulations. Employee training programs emphasize hygiene practices and proper handling procedures, reinforcing a culture of safety throughout the organization. Packaging design plays a vital role in the marketing and distribution of whipped cream. Modern factories invest heavily in developing attractive and functional packaging solutions that appeal to consumers while protecting the product. Innovations in material science have led to the creation of lightweight yet durable containers that reduce shipping costs and environmental impact. Resealable caps and ergonomic handles enhance user convenience, making it easier for customers to enjoy the product without compromising freshness. Supply chain management is another critical component of successful whipped cream production. Efficient logistics ensure a steady flow of raw materials into the factory and finished goods out to retailers. Strategic partnerships with suppliers help secure reliable sources of high-quality cream, while relationships with distributors facilitate rapid delivery to diverse markets. Real-time data analytics enable factories to forecast demand accurately, optimizing inventory levels and reducing waste. Research and development remain central to the growth of the whipped cream industry. Scientists and engineers continuously experiment with new formulations, processing techniques, and packaging technologies to improve product quality and sustainability. Emerging trends in biotechnology and fermentation offer promising avenues for enhancing flavor profiles and extending shelf life. Collaborations with academic institutions and research organizations provide valuable insights into cutting-edge developments that can be applied to commercial production. The economic impact of whipped cream production extends far beyond the factory floor. It supports jobs in agriculture, transportation, retail, and related industries, contributing significantly to local and national economies. By investing in community initiatives and sustainable practices, manufacturers demonstrate their commitment to corporate responsibility and long-term viability. Programs aimed at reducing carbon footprints, conserving water, and promoting biodiversity align with broader societal goals of environmental stewardship. As consumer preferences evolve, so too does the nature of whipped cream production. Health-conscious individuals seek products with fewer additives and artificial ingredients, driving manufacturers to adopt cleaner label approaches. Clear communication about ingredient sourcing and production methods builds trust and fosters loyalty among discerning customers. Educational campaigns highlighting the benefits of whipped cream as part of a balanced diet further reinforce its position as a staple in kitchens worldwide. Finally, the future of whipped cream production promises exciting possibilities. Advances in automation, digitalization, and artificial intelligence will likely transform traditional manufacturing processes, enabling greater efficiency and flexibility. Personalized nutrition platforms may one day allow consumers to customize their own whipped cream blends based on individual dietary needs and preferences. Meanwhile, ongoing efforts to reduce environmental impact and promote social responsibility will ensure that whipped cream remains a beloved and sustainable choice for generations to come. Through precise control of every stage, From cream procurement to final packaging, factories ensure that each container of whipped cream delivers consistent quality and satisfaction. This exploration reveals the depth and complexity behind the seemingly straightforward process of making whipped cream, highlighting the dedication and expertise required to bring this indispensable product to tables everywhere. The process begins with the sourcing of raw ingredients, including hazelnuts, sugar, cocoa powder, palm oil, skim milk powder, and vanillin. These ingredients are delivered to Nutella factories in massive quantities, requiring large-scale handling infrastructure. Hazelnuts, one of the key components of Nutella, are often sourced from Turkey and Italy, two of the largest hazelnut producers in the world. Upon arrival at the factory, hazelnuts are stored in enormous silos or temperature-controlled storage rooms to maintain their freshness. The silos are made of food-grade stainless steel and designed to protect the nuts from humidity and contamination, while allowing for precise dispensing into the production line. The first step in processing the hazelnuts is cleaning. Hazelnuts arrive in bulk shipments, often mixed with debris such as shells, stems, and dirt. To address this, the factory uses a series of cleaning systems that include vibrating screens, air classifiers, and magnetic separators. The vibrating screens shake the nuts to separate them from larger debris, while the air classifiers blow away lightweight impurities like husks and dust. Magnetic separators are also used to detect and remove any metallic particles that might have entered the shipment during harvesting or transport. Once cleaned, the hazelnuts undergo visual inspection using high-speed optical sorting machines equipped with cameras and sensors. These machines identify and remove any defective hazelnuts, such as those with discoloration, cracks, or signs of mold. After cleaning, the hazelnuts move to the roasting stage. Roasting is a crucial step in developing the rich, nutty flavor that characterizes Nutella. In the factory, this is achieved using massive industrial roasting ovens. These ovens are designed with rotating drums or conveyor belts to ensure even roasting. The temperature is carefully controlled, typically ranging between 280 and 320 degrees Fahrenheit, depending on the size and moisture content of the hazelnuts. Sensors monitor the temperature and time to ensure consistency, as over-roasting can lead to bitterness, while under-roasting can result in a lack of flavor. The entire roasting process is automated, and the equipment is designed for continuous operation to handle the high volume of hazelnuts required for production. Once roasted, the hazelnuts are transferred to grinding machines. These machines are equipped with heavy-duty stainless steel blades and rollers that crush the nuts into a fine paste. The grinding process occurs in multiple stages, with each stage further reducing the particle size of the hazelnut paste. In the initial stage, the nuts are coarsely ground into a chunky paste. In the subsequent stages, the paste is refined into a smooth consistency, with particle sizes measuring less than 30 microns. This ultra-fine grinding is essential for achieving Nutella's creamy texture. The equipment used in this process, such as colloid mills and ball mills, is highly specialized and designed to operate under high pressure and at precise speeds. The resulting hazelnut paste is collected in large stainless steel tanks, where it is stored at a controlled temperature to preserve its flavor and consistency. While the hazelnut paste is being prepared, the other ingredients are processed in parallel. Sugar, which provides sweetness to Nutella, is delivered to the factory in bulk containers or tankers. Upon arrival, the sugar is unloaded into silos, equipped with pneumatic conveying systems. These systems use air pressure to transport the sugar from the silos to the milling area, where it is ground into a fine powder. Industrial sugar mills are used for this purpose, and the grinding process ensures that the sugar particles are small enough to dissolve uniformly in the mixture. The factory also incorporates sieving systems to filter out any impurities or oversized sugar particles before they proceed to the blending stage. Cocoa powder, another key ingredient, undergoes a similar process. The cocoa powder is stored in sealed silos to protect it from moisture and contamination. Before being added to the Nutella mixture, the cocoa powder is sifted through vibrating screens to break up clumps and ensure a fine, even consistency. This step is crucial for achieving the smooth texture of the final product, as any clumps could create inconsistencies during blending. Palm oil, which gives Nutella its creamy consistency and prevents separation, is stored in large, temperature-controlled tanks. These tanks are equipped with heating elements to keep the oil in a liquid state, as palm oil tends to solidify at room temperature. The oil is pumped through insulated pipes to the mixing area, where it is carefully measured and added to the blend. The precise control of temperature and flow rate is essential to ensure that the oil integrates smoothly with the other ingredients. Skim milk powder, which adds a subtle dairy flavor and contributes to the creamy texture of Nutella, is stored in sealed containers or silos to prevent exposure to air and moisture. Before being used, the milk powder is sifted and screened to remove any lumps. Factories use advanced pneumatic conveying systems to transport the milk powder from the storage silos to the mixing area, ensuring that the ingredient is handled efficiently and hygienically. The blending process is the heart of Nutella's production, where all the prepared ingredients come together to form the final product. The blending tanks used in Nutella factories are massive, often with capacities of several thousand gallons. These tanks are equipped with high-speed agitators and temperature control systems. The hazelnut paste, sugar powder, cocoa powder, skim milk powder, palm oil, and vanillin are added to the tank in precise proportions, which are controlled by computerized dosing systems. These systems are programmed to weigh and dispense each ingredient accurately, ensuring consistency across batches. During blending, the mixture is heated slightly to help the ingredients combine more effectively. The temperature is carefully monitored, as excessive heat could alter the flavor and texture of the product. The blending tanks are designed to ensure even mixing, with agitators that create a vortex to incorporate all the ingredients thoroughly. The result is a homogeneous mixture with a smooth, creamy consistency. Once the blending process is complete, the mixture undergoes a refining stage. Refining is a critical step that ensures the final product is free of any graininess. The refining process takes place in multi-stage roller mills, which are equipped with heavy-duty steel rollers. These rollers apply immense pressure to the mixture, reducing the particle size of any remaining solids to less than 20 microns. This process not only enhances the texture of Nutella, but also improves its spreadability. The roller mills are fitted with precision sensors that monitor the pressure and temperature during refining, ensuring optimal performance. After refining, the mixture is transferred to the conching stage. Conching is a process borrowed from chocolate manufacturing and involves agitating the mixture in large, heated tanks for several hours. This process helps to further smooth the texture and enhance the flavor of the spread by allowing volatile compounds to evaporate and by evenly distributing the fats and solids. The conching tanks are equipped with paddles or rollers that knead the mixture continuously. The temperature and duration of conching are carefully controlled, as over-conching could negatively affect the spread's consistency. The finished Nutella is then pumped into holding tanks, where it is kept at a controlled temperature until it is ready for packaging. These tanks are equipped with agitators to prevent separation and maintain the spread's uniformity. Before the Nutella is packaged, it undergoes a final round of quality control. Samples from each batch are tested for flavor, texture, color, and viscosity. The factory uses advanced laboratory equipment such as viscometers and spectrophotometers to ensure that the product meets the company's stringent standards. Any deviations from the desired specifications are identified and corrected before the product proceeds to the packaging stage. Packaging is the final step in Nutella's production process, and it is carried out with the same level of precision and efficiency as the earlier stages. The spread is pumped from the holding tanks into automated filling machines, which dispense precise amounts of Nutella into jars. The filling machines are equipped with high-speed nozzles that can fill hundreds of jars per minute. Each jar is made from food-grade plastic or glass and arrives at the factory pre-sterilized to ensure hygiene. The jars are sealed with tamper-proof lids, which are applied and tightened using automated capping machines. Once the jars are sealed, they are conveyed to labeling stations, where Nutella's iconic branding is applied. The labels include important information such as the lot number, production date, and expiration date, which are printed using high-speed inkjet or laser printers. After labeling, the jars are inspected by vision systems that check for defects such as misaligned labels or damaged seals. Any defective jars are automatically removed from the production line. The jars are then packed into cardboard cartons using robotic packing systems. These systems are programmed to arrange the jars in specific configurations to maximize space and protect the jars during transportation. The cartons are sealed and stacked onto pallets using robotic palletizers. The pallets are then wrapped in plastic film for stability and loaded onto trucks or shipping containers for distribution. The entire packaging process is designed for high efficiency, with minimal manual intervention and maximum output. Throughout the factory, automation plays a key role in maintaining efficiency and consistency. Programmable logic controllers and supervisory control and data acquisition systems are used to monitor and control every aspect of the production process. These systems provide real-time data on parameters such as temperature, pressure, and flow rates, allowing operators to make adjustments as needed. The factory is also equipped with advanced robotics and machinery that ensure smooth operation, from ingredient handling to final packaging. Hygiene and safety are top priorities in Nutella factories. Production areas are constructed with food-grade stainless steel surfaces and epoxy-coated floors that are easy to clean and sanitize. Air filtration systems maintain a clean environment by preventing airborne contaminants from entering critical zones. Employees follow strict hygiene protocols, including wearing protective clothing and washing their hands regularly. The factory is regularly inspected to ensure compliance with international food safety standards, guaranteeing that every jar of Nutella is safe for consumption. This intricate, highly automated process ensures that Nutella is consistently smooth, flavorful, and delicious, meeting the high expectations of its millions of fans worldwide. Every step, from the handling of raw ingredients to the final packaging, is a testament to the engineering and precision that go into creating this beloved spread. The result is a product that continues to delight consumers, one jar at a time. Peanut butter, a staple spread beloved worldwide for its creamy or crunchy texture, requires a sophisticated and highly organized manufacturing process to meet the demand for consistent quality and flavor. Behind every jar of peanut butter is an intricate factory process that starts with the raw peanuts and ends with precisely packaged jars ready for distribution. Let's take an in-depth look at the factory production process, exploring the machines, systems, and engineering techniques that make it all possible. The process begins with the sourcing of raw peanuts. These peanuts are typically grown in countries like the United States, China, India, and Argentina, which are among the largest producers of peanuts globally. Peanuts are harvested in vast quantities, cleaned and dried at their source before being shipped to peanut butter manufacturing facilities. Factories require a consistent supply of high-quality peanuts, and to ensure that the raw peanuts are often tested upon arrival for size, moisture content, and overall quality. This ensures only the best peanuts are used for processing. Upon arrival at the factory, peanuts are stored in massive silos or bins designed specifically for food products. These silos are constructed from food-grade stainless steel or coated steel to prevent contamination and ensure proper hygiene. Inside the silos, the peanuts are protected from moisture, pests, and temperature fluctuations. These storage systems are equipped with conveyor systems that efficiently transfer peanuts from the silos to the initial cleaning and processing stages. The first step in processing peanuts is cleaning. Even though peanuts are partially cleaned at their source, factories implement a rigorous cleaning process to ensure no foreign materials or impurities remain. Vibrating screens are used to remove debris such as dirt, stones, and small sticks. Air classifiers blow air through the peanuts to remove lighter debris such as peanut skins or husks. Magnets are also employed to extract any metallic impurities. Optical sorting machines equipped with cameras and sensors scan each peanut as it moves along a conveyor belt, automatically removing any defective peanuts, including those with discoloration, mold, or deformities. After the cleaning process, the peanuts proceed to the roasting stage. Roasting is a critical step in peanut butter production, as it develops the rich, nutty flavor that defines the final product. Factories use industrial roasting ovens to roast the peanuts at controlled temperatures. These ovens come in two main types: batch roasters and continuous roasters. Batch roasters are used for smaller production lines, while continuous roasters, which use conveyor belts to move peanuts through a heated chamber, are used for larger scale operations. The temperature in these roasters typically ranges from 300 to 350 degrees Fahrenheit. The roasting process is closely monitored with temperature sensors and automated control systems to ensure the peanuts are roasted evenly. If some peanuts are over-roasted, they can turn bitter, while under-roasted peanuts may lack flavor. The level of roasting can also be adjusted depending on whether the final peanut butter will have a mild or more robust taste. Once roasted, the peanuts are cooled to stop the cooking process. Cooling is achieved by passing the roasted peanuts through chambers with powerful fans or cool air blowers. This step is crucial because it prevents the peanuts from continuing to cook, which could lead to inconsistencies in flavor. Some factories also use a water spray system to rapidly cool the peanuts, though this is less common as it can add moisture to the product. The cooling systems are designed to operate continuously to keep pace with the output of the roasting ovens. With the peanuts roasted and cooled, the next step is to remove their skins and separate the kernels. Skin removal is done using blanching machines. These machines have rotating drums or abrasive rollers that rub the peanuts, causing the thin outer skin to flake off. Some systems use steam blanching, where the peanuts are exposed to high-pressure steam to loosen the skins before mechanical removal. After blanching, the peanuts pass through air classifiers that blow away the loose skins, leaving behind clean peanut kernels. Factories also use gravity separators to sort peanuts by size and density, ensuring that only uniform peanuts proceed to the grinding stage. Before grinding, the peanuts are inspected again for quality. This is done using high-speed optical sorters that ensure any remaining defective peanuts are removed. Factories often have automated weighing and proportioning systems at this stage to determine the exact amount of peanuts needed for each batch. This level of precision is crucial for maintaining consistency in the flavor and texture of the peanut butter. The grinding process is the heart of peanut butter production. The roasted peanuts are fed into industrial grinders, where they are crushed into a fine paste. This process happens in multiple stages, beginning with coarse grinding and followed by finer grinding. The equipment used for this includes hammer mills and roller mills, which are specifically designed to reduce the peanuts into small, uniform particles. In many factories, the particle size is reduced to less than 20 microns, which is smaller than the diameter of a human hair. Achieving such a fine consistency is essential for the creamy texture that many consumers expect from peanut butter. For crunchy peanut butter, the process is slightly different. In these cases, a portion of the peanuts is coarsely ground and set aside before the final blending stage. These larger peanut pieces are later mixed into the smooth paste to create the characteristic crunchy texture. To prevent the peanut butter from separating, stabilizers such as hydrogenated vegetable oils or palm oil are added during the grinding process. These oils help bind the natural peanut oils to the solid peanut particles, ensuring a smooth and stable product that doesn't separate in the jar. Salt and sugar are also added at this stage to enhance the flavor of the peanut butter. Factories use precision dosing systems to measure and add these ingredients in exact proportions, ensuring every batch has the same taste. After grinding, the peanut butter is sent through a mixing stage, where it is further blended in large stainless steel tanks equipped with high-speed agitators. This stage ensures that the stabilizers, salt, and sugar are evenly distributed throughout the peanut butter. These tanks are often heated slightly to keep the peanut butter at the right consistency for mixing. The temperature is carefully controlled, as overheating can alter the flavor or texture of the peanut butter. Once the mixing is complete, the peanut butter undergoes quality control checks. Samples from each batch are tested in an on-site laboratory for flavor, texture, and consistency. Advanced instruments, such as viscometers, are used to measure the viscosity of the peanut butter, ensuring it meets the desired standards. Factories also use particle size analyzers to confirm that the peanut butter's texture is smooth and uniform. These quality checks are critical, as even slight variations can impact the final product's appeal to consumers. The final step in the manufacturing process is packaging. The peanut butter is pumped from the mixing tanks to filling machines, where it is dispensed into jars. These filling machines are capable of handling thousands of jars per hour, ensuring high efficiency. The jars, typically made of food-grade plastic or glass, arrive at the factory pre-cleaned and are sterilized again before filling. The filling nozzles are designed to dispense precise amounts of peanut butter into each jar, ensuring uniform weight and volume. Once the jars are filled, they move to the capping machines, where tamper-proof lids are applied and tightened. After capping, the jars are conveyed to labeling machines, which apply the brand's signature labels, along with lot numbers and expiration dates for traceability. Vision systems inspect each jar to ensure that the labels are correctly applied and that there are no defects in the seals or packaging. The jars are then packed into cardboard boxes using robotic packing systems. These robots are programmed to arrange the jars in specific configurations to optimize space and protect the jars during transportation. The boxes are sealed and stacked onto pallets using automated palletizing systems. Finally, the pallets are wrapped in plastic film for stability and loaded onto trucks or shipping containers for distribution. Throughout the entire production process, automation plays a vital role in maintaining efficiency and consistency. Factories are equipped with programmable logic controllers, PLCs, and supervisory control and data acquisition, SCADA systems, that monitor and control every aspect of production. These systems provide real-time data on parameters such as temperature, pressure, and flow rates, allowing operators to make adjustments as needed. Robotic systems handle many tasks, from sorting and cleaning peanuts to packaging the final product, reducing the need for manual labor and ensuring precision. Hygiene and safety are also top priorities in peanut butter factories. The production areas are constructed with food-grade stainless steel surfaces and epoxy-coated floors that are easy to clean and sanitize. Positive air pressure systems prevent airborne contaminants from entering critical zones, while strict hygiene protocols ensure that employees maintain cleanliness throughout the production process. The entire facility is regularly inspected to comply with international food safety standards, ensuring that every jar of peanut butter is safe for consumption. Peanut butter production is a complex and highly technical process that relies on advanced machinery, precise engineering, and rigorous quality control. From the cleaning and roasting of peanuts to the grinding, mixing, and packaging of the final product, every step is designed to create a spread that is smooth, flavorful, and consistent. Factories operate with remarkable efficiency, producing thousands of jars per day to meet the global demand for this versatile and beloved product. Strawberry jam production is a fascinating and highly engineered process that combines precision machinery with time-tested techniques to create a smooth, fruity spread. At the core of this process are high-quality strawberries, sugar, pectin, and citric acid, all carefully handled and processed to achieve the perfect consistency and flavor. Inside a modern jam factory, every step is optimized for efficiency, consistency, and food safety. The process begins with the selection and delivery of fresh or frozen strawberries. Factories typically source strawberries from local farms or large-scale suppliers. Frozen strawberries are often preferred for large-scale production because they are preserved at peak ripeness, ensuring consistent flavor year-round. The strawberries arrive in bulk containers and are stored in cold rooms or freezers to maintain their quality until processing begins. Before entering the production line, the fruit undergoes a thorough cleaning process. This includes washing the strawberries in large tanks filled with filtered water, where gentle agitation removes dirt, debris, and any residual pesticides. Once cleaned, the strawberries pass through optical sorting machines. These machines use cameras and sensors to identify and remove defective or discolored fruit. Advanced systems can even detect minute imperfections, ensuring that only the highest quality strawberries make it into the jam. After sorting, the strawberries are sent to cutting or mashing machines, depending on the desired jam texture. For chunkier jams, strawberries are coarsely chopped, while for smooth spreads, they are mashed or pureed into a uniform consistency. The fruit then enters large stainless steel cooking kettles or continuous cooking systems. In these vessels, the strawberries are combined with sugar, which not only sweetens the jam, but also acts as a... The sugar is added using automated dosing systems that measure precise quantities to ensure consistent flavor. Pectin, a natural thickening agent derived from fruit, is added to help the jam set. Citric acid is also incorporated to balance the sweetness and enhance the fruit's natural flavor. The mixture is slowly heated, with temperatures reaching up to 220 degrees Fahrenheit to activate the pectin and achieve the ideal gel-like consistency. During cooking, the jam undergoes constant agitation to prevent scorching and ensure even heating. Steam-jacketed kettles or vacuum cookers are often used, as they allow for rapid and uniform heating. Modern vacuum systems are particularly advantageous because they enable cooking at lower temperatures, preserving the fresh flavor and bright color of the strawberries. Throughout the cooking process, sensors monitor the temperature, pH levels, and viscosity of the jam, ensuring that the final product meets strict quality standards. Once the jam reaches the desired consistency, it is pumped through a series of filters to remove any seeds or large pieces if a smoother texture is desired. The finished jam is then transferred to filling machines. These machines dispense precise amounts of jam into sterilized glass jars or plastic containers. The jars are immediately sealed with tamper-proof lids to maintain freshness and prevent contamination. After sealing, the jars are passed through pasteurization tunnels, where they are briefly heated to destroy any remaining microorganisms. Finally, the jars are labeled, inspected, and packed into cartons using robotic packaging systems. The entire process is highly automated, ensuring efficiency and consistent quality, from the arrival of fresh strawberries to the delivery of jars to store shelves. This seamless blend of traditional cooking techniques and advanced technology ensures that every jar of strawberry jam is rich in flavor, perfectly textured, and safe for consumers to enjoy. Come on, you're telling me sausages aren't your forever love? You've got to be kidding, because it's almost impossible to leave sausages untouched on the plate. As I felt you deserve to know how factories make your favorite sausages, I've managed to get inside the processing plant. Let's begin with the fresh, clean meat carefully fed into the machine, ensuring it's boneless to avoid any processing issues. It's divided into portions to constantly send them into huge grinders, bit by bit. This step-by-step approach guarantees that the meat is perfectly processed without any lumps, achieving perfection in every bite. As they choose to give the sausages a perfect blend and mouth-watering flavors, they work on the mixed meats, which involve frozen meat too. Just to inform you, freezing the meat at low temperatures for a specific duration kills parasites and bacteria, crucial for the safety of sausages. This process not only enhances their shape to perfection, but also extends the shelf life of these savory treats, giving them a smooth, buttery texture. You can see how beautifully the entire meat is shredded and chopped. Buckle up because it's going to be rich and smooth, just as you like. In the next step, a mix of spices or herbs is added for great flavor. It's all in the blend of spices and meats. Some are spicy with a kick of pepper, while others are mild, so they will cook perfectly. Ice adds moisture to the mixture, so it's added in small amounts to help achieve the desired juiciness and consistency in the final product. Keeping the mixture cold makes it easier to mix the ingredients evenly, ensuring a consistent flavor throughout the sausage production. You can see how the frozen meat and spices blend smoothly into a soft, even texture after being expertly ground, along with a bunch of ice being added in intervals and some other runny but important ingredients. Here come the eggs, a lot of them. These automatic machines are responsible for cracking the eggs and separating the yolks from the whites, because only yolks are needed. This isn't a challenge, thanks to these machines. The yolks are then whisked into the mixture to ensure a lump-free blend. This perfected mixture is then seamlessly integrated into the ground meat, crafting delicious sausages packed with savory flavors and made in countless delicious varieties. Sausages are a favorite food around the world. Now comes the next step, preparing the natural casing for sausages. It's soaked in cool water for at least 30 minutes to several hours, ensuring it's thoroughly washed to remove any residual salt and all prepared. It's moisturized with a touch of water to prevent drying and maintain its perfect form. The sausage mixture is carefully piped into the machine, ensuring it's shaped into specific sizes. See how these sausages emerge, perfectly shaped and glistening with a shiny finish, ready to delight your taste buds. Check out this natural casing holding your favorite sausage material. Just look at that consistency. After cutting, these sausages are coated with various flavorful sauces and undergo a pre-drying procedure for several hours. Your favorite sausages are now undergoing the crowning smoking process, which helps them gain that delicious flavor. This process also serves several purposes, which we'll expose in a bit. Finally, they move to the post-drying stage, where the changing color enhances their delicious appeal. In the next stage, they are prepared with natural sausage casings, evenly and securely tied to avoid air pockets. Stainless steel hooks or wooden rods are used to hang the sausages, ensuring they are evenly spaced to allow for adequate airflow between each one. This thoughtful arrangement ensures that during the drying and smoking process, Each sausage receives consistent exposure to smoke and air, enhancing flavor and texture uniformly. Smoking sausages serves two main purposes. First, it adds a delicious smoky flavor that many people love. Secondly, smoking helps extend the shelf life of sausages. The smoke contains natural compounds that act as preservatives, helping to prevent spoilage and bacteria growth. This means sausages can last longer without the need for artificial additives. So yeah, smoking isn't just about taste. It's a smart way to preserve and enhance one of our favorite foods. After completing the drying process, the hanging sausages are carefully removed from the hooks or rods. Their color has transformed beautifully during this stage. Next, they are swiftly fed into a high-speed robotic system, where they are separated with precision using powerful air pressure. As they are getting ready, just imagine them perfectly tucked into a warm bun with mustard and onions. My goodness, I can barely focus now. Of course, how could we forget about the packaging? Each sausage is packed as carefully as it was crafted. They are placed in preset quantities in their desired boxes. Watch powerful hands tirelessly prepare the casing for sausages, but there's also a little friend that helps to fill up these casings automatically. Now they shape each sausage using precise measuring instruments and then carefully mold them by hand, preparing them for the drying process. For drying, each sausage is carefully hung one by one on iron rods, ensuring they attain the perfect shape and form. After a precise inspection to ensure top-notch quality, these savory treasures hang to dry and cure in a controlled environment, where their flavors deepen and mature. Maybe next time, before grabbing another bite of sausages, you will remember and appreciate the effort behind making those delicious sausages you eat. You might know those cheese cravings that refuse to quit until you take that first bite. Who's nodding along with me on this? If you can't resist grabbing a slice, even in the middle of the night, maybe we're in this together. Let's get straight to the stables, where hundreds of these beauties are kept safe and sound. And when I say safe and sound, I mean it. If you're wondering whether these cows are wearing yellow-colored earrings, no, in fact, they've got their number tags, so no cow is left unattended, and every beauty gets equal protocol regularly. You've probably heard that only healthy and happy cows provide nutrient-packed milk, so their diet and cleanliness are top priorities for farmers. Hey, stop. Where are y'all going? Oh, the milking facility. Let me show you around. This is the basic milking process that involves a bit of manual help, like installing the automatic milking devices and noting the required time to remove them immediately. Does that seem like a hassle to you? Worry not. I've saved 100% milking automation for you guys, so stick around until I get permission to show you the most secure and advanced milking facility. You might wonder how these cows cooperate so well. It's quite clear. Each cow is lured to its spot with its favorite food as positive reinforcement. The milking devices literally take a few seconds to detect the milking spots and connect to them automatically. Literally, no human hand is needed. This high-tech milking process can be completed in just 5 to 7 minutes, whereas hand milking can take much longer. Did you know that dairy cows are typically milked 2 to 3 times a day, ensuring a steady supply of fresh milk? It's true. Automated machinery offers immense benefits, yet many still prefer the old-school manual methods. These devices are directly connected to individual drums, where the milk is automatically collected without any outside contact, straight from cows to the drums. One major perk of large-scale milk production in factories is that human effort, once solely for milking, is now redirected to even more valuable tasks. Some advanced technology factories even use sophisticated milk meters to tally up each cow's milk production with high precision. After milking, an automated cleaning system sanitizes the equipment to maintain proper hygiene, keeping things squeaky clean. Large-scale production has now reached sky-high levels as we step into this magical world of mozzarella cheese. Every move follows precise guidelines. First, the fresh milk is poured and pasteurized to make it ready for cheese production, and of course, to kill any possible harmful bacteria present. This man carefully adds rennet, an enzyme, and some starter cultures like lactic acid bacteria to prepare the healthy curd for cheese processing. Rennet helps to coagulate the milk, while the bacteria acidify it, keeping the desired thick consistency of the curd they need. Once the curd reaches the right consistency, they use huge sieves, or special knives, to cut the curd into smaller pieces. This will help the curd to separate from the whey easily. The more it rotates, the more whey gets separated, giving the paramount cheese curd. It's getting easier to transfer into larger pots for further processing. Once collected into bigger, wide-open pots, these curds need to be cooled to room temperature, so it's easier to process the cheese curd further. It's good to test any step beforehand rather than improvising the whole thing at a bigger level. time to shred the large cubes of solid curd into smaller chunks. If you've ever made mozzarella cheese at home, you'd probably know why this step is important, except now it's on a larger scale. As soon as the curd cubes are shredded into fine, smaller chunks, hot water is added through pipes to make the curd flexible for kneading. Yep, it's the most fascinating part of the entire cheese processing. This spinning or kneading is the most difficult part of the process because if you don't soften it just right, the mozzarella won't turn out to be the best you've always loved. But thanks to those experts, they can handle bulk production with so much care, never compromising on our stubborn taste buds. Once the cheese is kneaded perfectly, they just need to make small balls of cheese, and the machines will collect them automatically. Look how conveniently those mini cheese balls come out of their dedicated zones. Using a constantly running water stream makes the process way smoother. Let me walk you through some very curious stuff. Did you know that as cheese ages, it naturally changes its texture? Yes. With time, its moisture content decreases, resulting in a firmer, more crumbly texture that enhances its overall appeal. Some cheeses even develop a protective rind during aging, which not only preserves moisture, but also adds depth to its flavor profile. Unlike traditional manual methods, where each step requires significant human effort and time, automated systems streamline the process, allowing for faster production rates without compromising the integrity of the final product. This results in fresher, longer-lasting products that retain their flavor and texture until they reach consumers' tables. The right pH level ensures curds achieve their perfect texture, whether silky smooth or delightfully firm and stretchy. Who doesn't love vibrant colored ice popsicles in the summer? A special mixture for ice pops is poured into molds of specific shapes and left to set with sticks neatly in place. Of course, its appeal goes beyond just being a treat for kids. After a short time, all it takes is a cool temperature, and they fit perfectly into their molds. Recent research in the United States reveals that bulk ice pop production in factories boosts efficiency by up to 50%, cutting down on production costs while ensuring consistently high-quality treats for everyone to savor. Efficient packaging ensures that the ice pops are properly protected during transportation and storage, maintaining their quality and preventing any damage. Freshly harvested potatoes arrive at the factory, where the chosen potatoes are gently loaded onto a conveyor belt. This belt carries them smoothly into the heart of the washing area, where a steady stream of water showers over them. This stage is crucial for maintaining the potatoes' hygiene and ensuring they are free from any contaminants that could compromise their quality. After the initial rinse, the potatoes enter a brushing and scrubbing phase. Here, soft brushes mounted on rotating cylinders gently massage the potato skins. Once thoroughly washed, the clean potatoes proceed to a drying stage. This step is typically 2 in 1. They dry naturally while moving ahead toward further processing. Peeling, obviously. The potatoes enter the automatic peeling station, where abrasive rollers gently remove their skins. They are then moved to large choppers, which cut the potatoes into uniform chunks. This factory is truly multitasking, as it doesn't only prepare potatoes for silky smooth mashed potatoes, but also for various cuisines. For example, special cutters slice the potatoes into wedge shapes, so potato wedges are no longer a hassle. While some peeled potatoes are sent for further examination, experts pass the good quality potatoes to be cut into halves and packed immediately. Yes, because we can't wait to show you the satisfying process of making mashed potatoes in bulk. To prepare the creamiest and most flavorful mashed potatoes, the experts boil the potatoes right on the spot. While in many households, like mine, where spare time is an issue, already boiled potatoes, cooked a day or two before, are used to make mashed potatoes quickly. These experts know never to compromise on taste. When the potatoes are perfectly boiled, the unnecessary water is drained, and the steamy hot potatoes get their royal treatment in a smooth blender. As the main character, the potatoes are blended while butter is added bit by bit to ensure a thorough and creamy mix. Talk about creamy. To make mashed potatoes even creamier and dreamier, a specific amount of milk is poured in and mixed all over again. This gives the mashed potatoes a smooth texture and perfect consistency, making you crave more. And there you have it. The superheroes have undergone the ultimate transformation and are ready to be served as a delicious creamy side dish or main course. It totally depends on your taste. Never underestimate any small element, even if it's a nozzle, pouring equal quantities of mashed potatoes into every batch. It was truly a team effort. One of the famous international frozen pizza companies is on a mission to create the most delicious pizza ever. They start off with smooth, fluffy dough, which is balled up and spread out neatly in thousands of pizza pans for quick and partial baking. Meanwhile, the pizza sauce is being prepared and spread neatly over the baked dough by automatic machines. No manual help needed. You know cheese could go bad, so before it ruins the entire pizza party, they check it for top-notch quality beforehand. Once it's deemed good enough, the crushers shred entire blocks of cheese and sprinkle it over thousands of pizzas to give them a perfect texture. Some more cheese slices are neatly added on top. Finally, they pour on other sauces and ingredients, preparing the pizzas to be frozen right away. The pizzas are covered with a transparent food sheet and packed into boxes to keep them fresh and preserved. These machines don't demand appreciation, but they deserve it, don't they? So hit the like button for the sake of these and many other robotic machines working tirelessly to give you perfect outcomes every time. Just check out how this ordinary looking dough transforms into perfect buns with a single push of a button. Yes, this entire automation doesn't involve any manual help. Once balled up and rested in their dedicated pans, these fluffy dough balls rise for a couple of minutes. The vacuum then blows off extra crumbs, giving them a neat, finished look. When the buns are perfectly baked, they're all set to get dressed. If you like our video, please give it a thumbs up and support us in creating more content for you guys. As I always say, you're all we have. Look at those nozzles pouring delicious jam onto each half, giving you the best mouth-bursting flavors. Let's indulge in the golden sweetness of honey candies, where each bite is a taste of pure honey. Here, the process begins with a blend of pure honey and other required ingredients, transformed by super smart rollers into a thick, delightful mixture. This mixture is rolled out consistently and kneaded thoroughly. Just look at that consistency. It's so rich and smooth. It's amazing how these machines continuously knead the candy material without taking a break to ensure it perfectly meets your standards. Now, the little automated machines ensure that each candy gets the perfect and desired shape and cut. As the candies move through the production line, quality control sensors monitor each piece. These sensors check for consistency in size, shape, and texture. Once the candies have cooled and set, they are transferred to the wrapping machine. This machine wraps each batch of candies in protective packaging, keeping them fresh and preventing them from sticking together. Each pack holds around 9 candies, loved worldwide for their pure taste and eye-catching packaging. The wrapped candies are then packaged into boxes using large-scale packaging machinery. This step prepares the candies for distribution, ready for shipping. Stop messing with your sweet tooth. Nature. Not everything sweet is worth tasting. So grab only your favorite honey top biscuits that are rich in taste and super affordable. Do tell me when you find one. Jelly Belly candies are true gummy delights that are crispy on the outside, but burst with mouthfuls of liquid flavor the moment you munch them. First, the ingredients are mixed together in a large machine until the mixture is just right. Once the mix is ready, the machines pour it into molds to shape the candies. Now it's time for their rest, which doesn't take too long. Once the candies cool down, they're removed from the molds and spun in a special machine to ensure they're the perfect size, shape, and texture. This process creates countless candies with tons of flavors to try. With so many different flavors, there's a Jelly Belly for every mood, and you're sure to find one you love. They ensure everyone can enjoy their favorite candy flavor and have a great time eating it. With so many different tastes, from fruity to sweet and everything in between, you'll never get bored. These treats turn snacking into a fun journey, letting you discover your new favorite flavor with every bite. When it comes to comparing super smart machines with human hands, robotic machines take the cake. They do everything super fast, perfectly, and with precision. Like right now, these machines are helping to create thousands of baked crusts to be filled with sweet and savory sauces for bakeries and restaurants. Loads of fresh meat are brought in and fed into a super fast chopping machine. This machine cuts it all into equal-sized pieces and neatly packs them into cans. Each tin is sealed tight and labeled with robotic precision in very little time. Creating perfect and smooth dough is a challenging task for human hands. However, for these magical machines, shaping dough into equal-sized pieces is no big deal. Once the dough is ready, the balls are prepared and undergo a smooth waffle-making process. This machine rolls and bakes the dough balls simultaneously, ensuring no additional time is wasted, with the results being absolutely flawless. In today's busy times, sandwiches are considered the perfect meal. Just pair one with a cup of coffee or tea for an easy energy boost. Advanced machinery prepares these sandwiches automatically, taking less time than you can imagine while packing a full energy punch. Different fruit flavors become uniquely delicious when transformed into sweet delights like candies. Robotic machines ensure these flavors are smooth and their textures consistent, making the taste incredibly delicious and enhanced. Robotic systems cut, shape, and create perfectly equal-sized candies in bulk in the blink of an eye. The candies are then moved to be wrapped in beautiful, eye-catching wrappers, ready to be enjoyed. Watch as these machines make the perfect donut-shaped sponge cakes, which are later topped and dipped into creamy, rich chocolate. Each donut is uniformly crafted and beautifully finished. To enhance the creamy flavor, a drizzle of chocolate syrup is added on top to make every bite a delightful experience. Once finished, they move on to the next process. The process begins with the careful selection and sourcing of raw ingredients. The primary components of KitKat bars include wheat flour, sugar, cocoa mass, cocoa butter, milk powder, vegetable oils, and emulsifiers. Nestlé, the brand behind KitKat, sources these ingredients from various regions worldwide, ensuring sustainability and adherence to strict quality standards. The cocoa used in KitKat is primarily sourced from the Nestlé Cocoa Plan, which promotes sustainable farming practices and fair trade. Once the raw materials arrive at the production facility, they undergo a series of inspections and tests to verify purity, consistency, and compliance with food safety regulations. This includes spectroscopic analysis for contaminants, moisture content testing, and sensory evaluations conducted by trained professionals. Once approved, the ingredients are stored in temperature-controlled silos and dispensing systems. The flour is kept in airtight storage to prevent contamination, while cocoa and milk powder are maintained under controlled humidity conditions to prevent clumping. Automated feeding systems transport these raw materials to the respective processing units, ensuring precise measurement and consistency in formulation. The first major step in KitKat production is wafer baking. The signature light and crispy wafer layers are created through a precise blending of wheat flour, water, sugar, and vegetable oils. Large industrial mixers, equipped with programmable logic controllers, ensure thorough mixing to produce a smooth and homogeneous batter. Once mixed, the batter is transferred via pressurized pumps to high-speed continuous wafer baking ovens. These ovens feature rotating baking plates that evenly distribute the batter across the surface, forming thin sheets of wafer. The baking plates operate at carefully controlled temperatures, typically around 180 to 200 degrees Celsius, ensuring uniform texture and color. The baked wafer sheets emerge golden brown and crisp, ready for the next stage. To enhance the crispness, the wafer sheets pass through a controlled cooling system. Conveyor belts transport the freshly baked wafers through a cooling tunnel, where calibrated fans gradually reduce the temperature to prevent thermal shock. The cooled wafers are then directed to the trimming and cutting station. Automated guillotine cutters trim the edges of the wafers to achieve uniform dimensions, ensuring consistency across all KitKat bars. Once trimmed, the wafers are transported to the layering station. Here, a fine layer of chocolate cream filling made from a precise blend of cocoa, sugar, and milk powder is evenly spread onto the wafers. Automated depositor machines ensure the filling is applied uniformly, maintaining the right thickness for optimal texture. The layering process continues with additional wafer sheets stacked on top, creating a multi-layered wafer slab. These slabs are then pressed under controlled pressure to bond the layers together without crushing the delicate structure. After layering, the wafer slabs proceed to the cutting stage. High-speed rotary or ultrasonic blade systems slice the large wafer sheets into precise rectangular portions, forming the individual KitKat fingers. Ultrasonic cutting technology is particularly effective in ensuring clean, precise cuts without generating excess crumbs or damaging the layers. The next crucial step is chocolate enrobing. The enrobing process begins with the preparation of molten milk chocolate, which is produced in large conching machines. These machines continuously grind and blend cocoa mass, cocoa butter, sugar, and milk powder, refining the mixture to achieve a smooth, velvety consistency. The conching process, which can last several hours, helps develop the rich, creamy texture and enhances the flavor profile of the chocolate. Once ready, the molten chocolate is fed into enrobing machines, where KitKat fingers pass through a curtain-like flow of chocolate. These enrobers ensure complete coverage, with excess chocolate removed using controlled air jets and vibrating conveyors. To achieve the signature glossy finish, the enrobed bars pass through a tempering unit, which carefully regulates the chocolate's crystallization process. This involves a precise cycle of heating, cooling, and reheating to stabilize the cocoa butter crystals, preventing bloom and ensuring a smooth, even texture. Following enrobing, the chocolate-covered KitKat bars enter a cooling tunnel. This tunnel, equipped with multi-zoned cooling technology, gradually reduces the temperature in stages to solidify the chocolate coating without causing cracks or condensation. The cooling process is carefully monitored using infrared sensors to maintain consistency. Once the chocolate is fully set, the KitKat bars move to the quality control and inspection stations. Advanced vision inspection systems, equipped with high-resolution cameras, scan each bar for defects, such as uneven coating, improper sizing, or misaligned layers. Bars that do not meet quality standards are automatically rejected by robotic sorting arms and sent for reprocessing. Additional quality checks include weight verification, moisture content analysis, and sensory testing conducted by trained specialists. After passing inspection, the KitKat bars are transported to high-speed wrapping machines. Individual bars are wrapped in foil or plastic film using heat sealing technology, ensuring airtight packaging that preserves freshness. These wrapped bars are then grouped into multi-packs, which are subsequently boxed using robotic case packers. The packaging design is carefully printed with product details, barcodes, and branding elements before final sealing. The packaged KitKat bars are then palletized for distribution. Automated palletizing systems stack the boxes onto pallets in a precise arrangement to optimize space utilization during transportation. These pallets are shrink-wrapped for stability and loaded onto temperature-controlled trucks for delivery to distribution centers worldwide. The logistics process is carefully coordinated to ensure timely delivery, with real-time tracking systems monitoring shipments from factory to retailer. Throughout the entire production process, extensive quality control measures are in place to uphold product integrity. Each batch undergoes rigorous laboratory testing, including microbiological screening, allergen testing, and texture analysis. Data from all processing stages is logged in automated tracking systems, and compliance with food safety regulations. While the fundamental principles of KitKat production remain consistent across different manufacturing plants, regional variations may exist to cater to local tastes and preferences. For example, KitKat flavors such as matcha green tea, strawberry, and sake are produced in Japan using specialized formulations. Some factories may also incorporate alternative chocolate blends, varying cocoa content to suit market demands. Nestlé continues to innovate and optimize KitKat production through advancements in automation, sustainability initiatives, and ingredient sourcing. Modern factories are increasingly utilizing AI-driven quality control systems, energy-efficient processing equipment, and eco-friendly packaging solutions to reduce environmental impact. With continuous improvements in manufacturing technology, KitKat remains a global favorite, offering consumers a consistently delightful chocolate experience in every bite. Mars bars, one of the most iconic chocolate confections in the world, are produced in highly sophisticated manufacturing facilities designed to ensure consistency, efficiency, and quality at every step of the process. The production of Mars bars involves multiple intricate stages, from sourcing and processing raw ingredients to forming, enrobing, cooling, and packaging the final product. Each step is meticulously controlled using advanced automation technology and stringent quality control measures to ensure the signature caramel, nougat, and chocolate combination is perfectly replicated in every bar. The process begins with the careful selection of raw ingredients. The main components of a Mars bar include sugar, cocoa mass, cocoa butter, skimmed milk powder, whey powder, palm fat, glucose syrup, lactose, milk fat, and egg whites. These ingredients are sourced from trusted suppliers and undergo rigorous quality assurance checks upon arrival at the factory. Sugar, which plays a crucial role in both the nougat and caramel layers, is stored in large silos, where it is kept dry and free from contamination. Cocoa products, including cocoa mass and cocoa butter, are stored in climate-controlled environments to prevent degradation. Dairy ingredients, such as skimmed milk powder and whey powder, are tested for purity and consistency before use. Once the raw ingredients are approved, the first major stage in Mars bar production is the creation of the nougat layer. Nougat is a key structural component of the bar, providing a soft, chewy texture that contrasts with the caramel and chocolate. The nougat making process begins in large industrial mixing tanks, where a combination of sugar, glucose syrup, and water is heated to create a syrup. This syrup is then aerated using a whipping system, which incorporates fine air bubbles to achieve the desired light and fluffy texture. During this stage, egg whites or hydrolyzed soy protein are added as stabilizers to maintain the nougat's consistency. Once the nougat mixture reaches the proper texture, it is transferred onto a continuous conveyor belt, where it is spread into an even layer. This belt passes through a cooling tunnel to allow the nougat to set before it reaches the next stage of the process. The cooled nougat layer is then precisely cut into rectangular strips using high-speed guillotine cutters. These strips will form the base of each Mars bar. The next step in the process is the caramel layer. The caramel used in Mars bars is created through a controlled cooking process that involves heating sugar, glucose syrup, and milk ingredients to high temperatures. This process requires careful monitoring to achieve the perfect balance of sweetness and viscosity. Industrial batch cookers equipped with automated temperature controls ensure that the caramel reaches the ideal consistency before it is deposited onto the nougat base. The caramel is applied as a continuous sheet over the nougat layer, ensuring even distribution and uniform thickness. Once the caramel is applied, the combined nougat and caramel layers proceed through a controlled cooling tunnel, where the temperature is gradually reduced to allow the caramel to set without becoming too hard or sticky. This ensures that the layers remain cohesive and easy to cut in the next stage of production. After cooling, the layered nougat and caramel sheets are fed into an automated cutting system, which uses precision blades to slice them into individual bar-sized portions. These freshly cut bars are then transported via conveyor belts to the enrobing station, where they receive their final chocolate coating. The enrobing process is a critical step in Mars bar production, as it gives the bars their signature smooth milk chocolate exterior. The chocolate coating is made from a blend of cocoa mass, cocoa butter, sugar, and milk powder, which is carefully tempered to achieve the perfect texture and glossy finish. The tempering process involves heating and cooling the chocolate in a controlled manner to ensure the cocoa butter crystals form a stable structure, preventing fat bloom and ensuring a smooth mouthfeel. At the enrobing station, the cut nougat and caramel bars pass through a curtain-like waterfall of molten chocolate, which fully coats them. Excess chocolate is removed using controlled air jets and vibrating conveyors to ensure an even layer without excessive buildup. Some factories use a two-stage enrobing process, where an initial thin layer of chocolate is applied as a base coat before the final, thicker chocolate layer is added. After enrobing, the chocolate-covered bars enter a multi-zone cooling tunnel, which gradually reduces their temperature in controlled stages. This cooling process allows the chocolate to set properly without developing cracks or a dull surface. The bars emerge from the cooling tunnel with a perfectly set chocolate shell, ready for the final stages of quality control and packaging. Quality control is a fundamental part of Mars bar production, ensuring that only bars meeting strict standards reach consumers. Automated vision inspection systems equipped with high-resolution cameras scan each bar for defects such as uneven coating, misshapen forms, or inconsistencies in size. Bars that do not meet the required specifications are automatically rejected and sent for reprocessing. Additional quality control measures include weight checks using precision weighing systems, texture analysis, and sensory evaluations conducted by trained specialists. Once the bars pass quality inspection, they proceed to the packaging area, where high-speed wrapping machines individually wrap each bar in foil or plastic film. These machines use heat sealing technology to create airtight packaging that preserves freshness and prevents contamination. The wrapped bars are then grouped into multi-packs and placed into branded cartons, which are sealed and labeled using automated case packing systems. The final step in the process is palletization and distribution. Automated palletizing systems stack the packaged bars onto pallets in a precise arrangement to optimize space utilization during transportation. The pallets are shrink-wrapped for stability and loaded onto temperature-controlled trucks for distribution to retail stores and supermarkets worldwide. The entire logistics process is carefully coordinated to ensure timely delivery while maintaining the product's freshness and quality. Throughout the entire manufacturing process, Mars maintains stringent quality control and food safety standards. Each production batch undergoes extensive laboratory testing, including microbial analysis, allergen testing, and moisture content verification. The company also invests in sustainable sourcing initiatives, ensuring that key ingredients such as cocoa and palm oil are responsibly sourced to minimize environmental impact. Different Mars manufacturing facilities may incorporate slight variations in processing techniques based on regional ingredient availability, consumer preferences, or proprietary formulations. Some facilities may use alternative chocolate blends with varying cocoa content to cater to specific markets, while others may modify the nougat formulation for textural differences. Additionally, Mars continuously invests in research and development to improve efficiency, reduce energy consumption, and enhance sustainability in its production processes. With advancements in automation, AI-driven quality control systems, and eco-friendly packaging innovations, the production of Mars bars continues to evolve while maintaining the signature taste and texture that consumers have loved for generations. Twix, one of the world's most beloved chocolate bars, is manufactured using a highly sophisticated and automated process that ensures each bar maintains its signature combination of crunchy biscuit, smooth caramel, and creamy milk chocolate coating. The production of Twix bars occurs in state-of-the-art factories that utilize precision engineering, cutting-edge food processing technology, and rigorous quality control protocols. From the sourcing of raw ingredients to packaging and distribution, every step is carefully orchestrated to guarantee consistency, efficiency, and superior taste. The process begins with the selection and procurement of high-quality raw materials. The key ingredients in Twix bars include wheat flour, sugar, palm oil, cocoa butter, skimmed milk powder, cocoa mass, lactose, whey powder, salt, and emulsifiers. These ingredients are sourced from carefully vetted suppliers who must meet strict food safety and sustainability requirements. For instance, the cocoa used in Twix bars is sourced through Mars' Cocoa for Generations initiative, ensuring ethical sourcing and environmental responsibility. Similarly, the palm oil used in the biscuits and caramel is certified sustainable to reduce environmental impact. Upon arrival at the manufacturing facility, the raw ingredients undergo thorough quality checks before entering the production process. These checks include spectroscopic analysis to detect contaminants, moisture content analysis to ensure freshness, and sensory evaluations to verify taste and aroma. Ingredients that meet the necessary standards are then stored in temperature-controlled silos and storage units to maintain their quality. The first step in the actual production process is the creation of the biscuit base. Twix bars are distinguished by their crunchy, shortbread-like biscuit layer, which requires precise preparation and baking. The process begins in large industrial mixers, where wheat flour, sugar, palm oil, and leavening agents are combined to form a dough. The mixing process is carefully timed to ensure the dough reaches the ideal consistency, firm enough to hold its shape during baking, yet tender enough to create the signature crisp texture. Once the dough is fully mixed, it is transferred to an automated sheeting system. This system rolls the dough into a uniform sheet of the exact thickness required for Twix bars. The sheeted dough then moves to a rotary cutting machine, which stamps out individual biscuit fingers. Each biscuit is precisely cut to ensure uniform size and shape, allowing for seamless assembly in later stages. The cut dough pieces are placed onto conveyor belts and transported into a large industrial baking oven. These ovens operate using a continuous baking system where the biscuit fingers travel through different heat zones that gradually bake them to perfection. The baking temperature is carefully controlled, typically ranging between 180 to 200 degrees Celsius, 356 to 392 degrees Fahrenheit, ensuring that each biscuit is evenly baked to a golden brown. Advanced infrared sensors monitor the biscuits throughout the baking process, ensuring uniformity in color, texture, and moisture content. Once fully baked, the biscuits pass through a cooling tunnel that gradually reduces their temperature, preventing cracking or breakage. Next, the caramel layer is prepared. The caramel used in Twix bars is made from a precise blend of sugar, glucose syrup, milk, and butter. This mixture is heated in large stainless steel batch cookers, where it undergoes controlled caramelization. The temperature and cooking time are crucial in achieving the perfect consistency, thick enough to stay in place on the biscuit, but soft enough to deliver a smooth, chewy texture. Once the caramel reaches the desired consistency, it is transferred to a continuous depositor system. This machine evenly dispenses a uniform layer of caramel onto each biscuit. The caramel application must be carefully controlled to ensure consistency in thickness across all bars. Any inconsistencies could lead to difficulties in chocolate enrobing or affect the final texture. With the caramel applied, the bars move along the conveyor belt to a cooling station, where they pass through a controlled cooling tunnel. This tunnel gradually reduces the temperature of the caramel, allowing it to set properly while maintaining its soft, chewy texture. After cooling, the caramel-coated biscuits are ready for the enrobing process, where they will be covered in rich milk chocolate. The enrobing process is one of the most critical steps in Twix production. The milk chocolate coating is prepared in large conching machines, which continuously grind and refine cocoa mass, cocoa butter, sugar, and milk powder. This process enhances the texture and flavor of the chocolate, ensuring a smooth, creamy consistency. The chocolate is then tempered, a controlled heating and cooling process that stabilizes the cocoa butter crystals. Proper tempering is essential to achieving the signature glossy finish and preventing fat bloom, white streaks that can appear on improperly tempered chocolate. At the enrobing station, the caramel-topped biscuits pass through a continuous chocolate waterfall. This ensures that each bar is fully coated in an even layer of chocolate. Any excess chocolate is removed using controlled air jets and vibrating conveyors, which help distribute the chocolate evenly without excessive buildup. Some factories employ a two-stage enrobing process, where a thin base coat of chocolate is applied first to ensure better adhesion before the final, thicker chocolate layer is added. Once the bars are coated, they enter a multi-zone cooling tunnel. This tunnel is divided into different temperature zones that gradually reduce the temperature, allowing the chocolate to set perfectly without cracking or becoming dull. The bars emerge from the cooling tunnel with a firm, glossy chocolate coating, ready for the next stage of production. Quality control is a top priority at every stage of Twix production. After cooling, the bars pass through a series of automated inspection systems. High-speed vision cameras scan each bar for inconsistencies in chocolate coating, caramel distribution, and overall shape. Any bars that do not meet specifications are automatically rejected and sent for reprocessing. In addition to visual inspections, quality control teams conduct random weight checks, moisture analysis, and sensory evaluations to ensure that each batch meets Mars's stringent quality standards. Once the bars have passed inspection, they move to the packaging stage. Twix bars are individually wrapped using high-speed horizontal flow wrapping machines. These machines use heat sealing technology to create airtight packaging that preserves freshness and prevents contamination. The wrapped bars are then grouped into multi-packs, which are sealed in branded cartons using automated case packing systems. After packaging, the final step in the process is palletization and distribution. Robotic palletizing systems stack the packaged bars onto pallets in precise arrangements, optimizing space for transport. The pallets are then shrink-wrapped for stability and loaded onto temperature-controlled trucks for distribution to retailers worldwide. Mars utilizes an advanced logistics network to ensure efficient delivery while maintaining product freshness. Throughout the entire production process, Mars adheres to strict food safety and sustainability standards. Each batch undergoes rigorous laboratory testing, including microbiological analysis, allergen testing, and texture verification. The company also invests in eco-friendly initiatives, such as reducing energy consumption in manufacturing and using recyclable packaging materials. Different Mars factories may employ slight variations in processing techniques based on regional ingredient availability and consumer preferences. For example, some regions may use alternative chocolate formulations with varying cocoa content, while others may adjust the caramel consistency based on market preferences. Additionally, limited edition Twix flavors, such as Twix white chocolate and Twix peanut butter, require modifications in ingredient formulation and processing techniques. As consumer demand for innovative flavors and healthier options grows, Mars continues to invest in research and development to improve Twix production. Recent advancements in AI-driven quality control, robotic automation, and sustainable ingredient sourcing are shaping the future of Twix manufacturing. Despite these innovations, the core principles of precision, consistency, and quality remain unchanged, ensuring that every Twix bar delivers the signature, crunchy, chewy, and chocolatey experience that consumers love. The making of a Hershey's chocolate bar is a complex, highly automated process that combines tradition with cutting-edge technology. From sourcing high-quality cocoa beans to wrapping the final product, every step is optimized for efficiency, consistency, and taste. The journey of a Hershey's bar begins with the careful selection of raw ingredients sourced from around the world. Cocoa, sugar, milk, and other ingredients are carefully tested to ensure they meet the company's high standards before they are transformed into the iconic chocolate bars that have been loved for generations. At the heart of every Hershey's chocolate bar is cocoa. The company sources its cocoa beans primarily from Ghana, Côte d'Ivoire, and Ecuador, regions known for producing high-quality beans with robust flavor profiles. Cocoa farmers in these areas harvest the ripe pods, extract the cocoa beans, and allow them to ferment for several days to develop their characteristic chocolatey taste. Once dried, the beans are shipped to Hershey's production facilities, where they undergo rigorous quality checks. Each shipment is tested for moisture content, flavor consistency, and the absence of contaminants. Only the highest quality beans make it through this stringent selection process. Once approved, the cocoa beans are sent to the roasting stage. Large industrial roasters expose the beans to carefully controlled heat, typically between 120 to 150 degrees Celsius, 248 to 302 degrees Fahrenheit, depending on the desired flavor profile. The roasting process is essential for developing the deep, complex flavors of chocolate. Different roasting profiles are used depending on whether the beans will be used for milk chocolate, dark chocolate, or other specialty products. After roasting, the cocoa beans enter the winnowing process. Specialized machinery cracks the roasted beans and removes the outer husks, leaving behind the valuable cocoa nibs. These nibs contain both the cocoa solids and cocoa butter needed for chocolate production. The nibs are then ground into a thick, dark paste known as chocolate liquor, which contains no alcohol despite its name. This chocolate liquor is the base for all Hershey's chocolate products. For Hershey's classic milk chocolate bars, chocolate liquor is combined with sugar, milk, and cocoa butter. The milk used in Hershey's chocolate is a key ingredient that gives it its distinctive taste. Unlike many European chocolates that use powdered or condensed milk, Hershey's uses fresh milk sourced from dairy farms in Pennsylvania and surrounding states. The milk is pasteurized and condensed before being blended with sugar to create a sweet, creamy base. The next stage in the process is refining. The chocolate mixture is run through a series of steel rollers that grind the particles to an ultra-fine consistency. This refining process is crucial for creating a smooth, melt-in-your-mouth texture. The finer the particles, the smoother the final chocolate will be. Once refined, the chocolate undergoes conching, a critical process that enhances flavor and texture. Conching machines, which resemble large industrial mixers, continuously stir the chocolate at controlled temperatures for several hours. This process aerates the chocolate, allowing unwanted acidic compounds to evaporate while enhancing its creamy mouthfeel. Hershey's uses a proprietary conching method that contributes to its signature flavor, which has a slightly tangy undertone due to controlled acidity in the milk. After conching, the chocolate moves to the tempering stage. Tempering is the process of heating and cooling chocolate in a precise manner to stabilize the cocoa butter crystals. Proper tempering ensures that Hershey's bars have a glossy finish, a firm snap, and a long shelf life. If the chocolate were not tempered correctly, it could develop fat bloom, a whitish streaking effect caused by unstable cocoa butter. Now, the tempered chocolate is ready for molding. Automated machines pour precise amounts of liquid chocolate into bar-shaped molds, which are then vibrated to remove air bubbles and ensure even distribution. The molds travel along a conveyor system into a cooling tunnel, where the chocolate solidifies into its final shape. Once cooled, the bars are ejected from their molds and transported via conveyor belts to the packaging area. Here, high-speed wrapping machines encase each bar in foil and branded paper sleeves, protecting the chocolate from moisture and light while ensuring a fresh, appealing presentation. Throughout the entire process, strict quality control measures are in place. High-resolution vision inspection systems scan each bar for defects, such as air bubbles, improper molding, or size inconsistencies. Bars that do not meet specifications are automatically rejected and sent for reprocessing. Additionally, random sensory evaluations are conducted by trained taste testers to ensure that the flavor, texture, and overall quality remain consistent. Once packaged, the final step is palletization and distribution. Automated robotic arms stack the packaged bars onto pallets, which are then shrink-wrapped for stability. These pallets are loaded onto temperature-controlled trucks and shipped to retailers worldwide. Hershey's operates an advanced logistics network that ensures timely delivery while maintaining product freshness. The entire manufacturing process is designed for efficiency, consistency, and sustainability. Hershey's continues to invest in eco-friendly initiatives, such as reducing water and energy consumption in production, using ethically sourced cocoa, and optimizing packaging materials to minimize waste. Different Hershey's factories may employ slight variations in processing techniques based on regional preferences and ingredient availability. Additionally, specialty products like Hershey's cookies and cream bars or Hershey's dark chocolate require modifications in ingredient formulation and processing times. As the chocolate industry continues to evolve, Hershey's remains at the forefront of innovation, combining tradition with advanced manufacturing techniques to produce its iconic chocolate bars. Through precision engineering, strict quality control, and a commitment to excellence, Hershey's ensures that every bar delivers the same beloved taste that generations have enjoyed. The making of Toblerone, the iconic triangular chocolate bar, is a masterclass in precision engineering, premium ingredient selection, and automated manufacturing processes. Unlike conventional chocolate bars, Toblerone stands out for its distinctive shape, rich Swiss milk chocolate, and the inclusion of honey and almond nougat. Every step, from sourcing the finest ingredients to molding the signature peaks, is meticulously controlled to ensure quality, consistency, and adherence to the Swiss chocolate-making tradition. The process begins with sourcing high-quality ingredients. Toblerone's signature flavor comes from its carefully selected components: Swiss milk, sugar, cocoa mass, cocoa butter, honey, almonds, and egg whites. The milk, sourced from Swiss dairy farms, is a critical ingredient that contributes to the creamy texture. The cocoa is sourced from sustainable farms in Ghana and Ecuador, where beans are hand-harvested, fermented, and dried under strict quality control measures. Almonds are procured from select suppliers, ensuring they meet the required standards of size, flavor, and crunch. The honey, a key component that adds a subtle sweetness, is sourced from European beekeepers specializing in high-quality aromatic varieties. Once the ingredients arrive at the production facility, they undergo rigorous quality checks. Advanced spectroscopic analysis, moisture content testing, and flavor profiling ensure that each ingredient meets the brand's high standards. The cocoa beans are then roasted at carefully controlled temperatures to develop their deep, complex flavor. Different roasting profiles are used depending on whether the beans will be used for Toblerone's milk, dark, or white chocolate variations. After roasting, the cocoa beans move to the winnowing stage, where high-powered machinery cracks them open and removes the husks. The remaining cocoa nibs, which contain the essence of the chocolate, are then finely ground into a thick, rich paste known as chocolate liquor. This forms the base of Toblerone's chocolate. The chocolate liquor is blended with sugar, cocoa butter, and Swiss milk powder to create the signature, smooth and creamy chocolate mixture. The next step in the process is refining. The chocolate mixture passes through a series of heavy-duty steel rollers that break down the particles to an ultra-fine consistency. This is crucial in achieving the signature melt-in-your-mouth texture. The refining process also helps blend the ingredients evenly, ensuring a perfectly smooth mixture. Following refining, the chocolate undergoes conching, a process that enhances its texture and flavor. Large conching machines continuously mix, aerate, and heat the chocolate for several hours, allowing volatile acids to evaporate and the flavors to develop fully. Toblerone's conching process is fine-tuned to create a silky texture and a well-rounded, rich taste. Meanwhile, the honey and almond nougat mixture is prepared in a separate area of the factory. Sugar, honey, and egg whites are heated and aerated to create a light, chewy nougat. Almonds, which have been roasted to bring out their nutty aroma, are chopped into small pieces and folded into the nougat mixture. The nougat is then cooled and ground into fine pieces before being incorporated into the chocolate. Once the chocolate has completed the conching process, the finely ground nougat mixture is carefully folded into it, ensuring even distribution. This step is crucial in maintaining the signature texture and taste of Toblerone. With the chocolate and nougat mixture fully blended, the next stage is tempering. Tempering is a precise process of heating and cooling chocolate in a controlled manner to stabilize the cocoa butter crystals. Proper tempering ensures that the chocolate has a glossy finish, a firm snap, and a smooth texture. Toblerone's tempering process is carefully calibrated to achieve the ideal consistency before molding. Molding is where Toblerone's iconic shape comes to life. The tempered chocolate is poured into custom-designed triangular molds that give the bar its distinctive peaks. The molds are gently vibrated to remove air bubbles and ensure even distribution of the chocolate. After molding, the bars pass through a cooling tunnel, where they are gradually cooled to allow the chocolate to set perfectly without cracks or imperfections. Once solidified, the bars are removed from the molds and transported to the quality control station. Each bar is inspected using high-resolution vision cameras, which detect any inconsistencies in shape, texture, or coating. Automated sorting systems remove any defective bars, ensuring that only perfectly shaped Toblerone bars proceed to packaging. The packaging process is designed to maintain the freshness and integrity of the chocolate. Toblerone bars are individually wrapped in foil to protect them from moisture and light, then placed into the iconic triangular cardboard cartons. High-speed packaging machines fold and seal the cartons with precision, ensuring that the bars remain securely enclosed. Following packaging, the bars are palletized using robotic systems, stacked carefully for stability during transport. These pallets are shrink-wrapped and loaded onto trucks for distribution to markets around the world. Temperature-controlled logistics ensure that the chocolate remains in perfect condition during transit. Throughout the entire manufacturing process, Toblerone maintains strict quality control measures. Each batch undergoes laboratory testing, including texture analysis, microbial screening, and taste assessments conducted by trained specialists. Data is continuously logged in automated tracking systems, allowing for full traceability of every Toblerone bar produced. Different Toblerone manufacturing facilities may employ slight variations in processing techniques depending on regional ingredient availability and market preferences. Specialty editions, such as Toblerone White Chocolate or Toblerone Dark, require slight modifications in ingredient formulations and processing steps. As consumer preferences evolve, Toblerone continues to innovate while maintaining the brand's heritage of Swiss chocolate craftsmanship. Investments in sustainable cocoa sourcing, eco-friendly packaging solutions, and advanced automation ensure that Toblerone remains a global favorite while reducing its environmental footprint. Through precision engineering, time-honored techniques, and a commitment to quality, every Toblerone bar delivers the signature taste and texture that chocolate lovers around the world cherish. The production of Snickers, one of the world's most popular chocolate bars, is a highly automated and meticulously controlled process designed for efficiency, consistency, and large-scale output. With its signature combination of nougat, caramel, peanuts, and milk chocolate, Snickers is produced in state-of-the-art facilities that use cutting-edge food processing technology, ensuring that every bar meets the brand's high-quality standards. From sourcing the finest raw ingredients to packaging and distribution, every step is optimized to deliver the same taste, texture, and satisfaction in every bite. The journey of a Snickers bar begins with the careful selection of raw materials. The main components include sugar, peanuts, milk powder, cocoa mass, cocoa butter, palm oil, glucose syrup, egg whites, and emulsifiers. These ingredients are sourced from carefully vetted suppliers, ensuring compliance with strict food safety and sustainability standards. Mars, the company behind Snickers, prioritizes responsible ingredient sourcing, ensuring that cocoa is ethically obtained through its Cocoa for Generations program, which promotes fair labor practices and sustainable farming methods. Peanuts, another crucial ingredient, are primarily sourced from the United States, where they are grown under controlled conditions to maintain size, flavor, and crunch. Once the ingredients arrive at the manufacturing facility, they undergo a rigorous quality control process. Each batch is tested for moisture content, purity, and potential contaminants. Peanuts, in particular, go through an additional inspection phase, where they are sorted by size and quality. High-speed optical sorting machines remove any defective or discolored peanuts, ensuring that only the best nuts make it into Snickers bars. The first major step in the Snickers production process is creating the nougat base, Nougat provides the chewy texture that forms the foundation of the bar. It is made by combining sugar, corn syrup, and water, which are heated in large industrial cooking vats to create a syrup. This syrup is then aerated using high-powered whipping machines, which incorporate fine air bubbles, giving the nougat its characteristic light and chewy texture. Egg whites or soy protein are added as stabilizers to help maintain consistency. Once aerated, the nougat is spread onto a moving conveyor belt in a continuous sheet, where it is allowed to cool and set. This process is carefully controlled to prevent the nougat from becoming too hard or too soft. Automated guillotine cutters then slice the nougat sheet into uniform rectangular portions, ensuring that each piece is the exact size required for Snickers bars. Next comes the caramel layer. The caramel in Snickers is made from a blend of sugar, glucose syrup, milk, and butter, which is heated in large stainless steel batch cookers. The temperature is carefully monitored to achieve the perfect viscosity, thick enough to hold its shape, but soft enough to provide a smooth, chewy texture. Once cooked to perfection, the caramel is poured in a controlled stream onto the nougat base. The caramel-covered nougat passes through a cooling tunnel, where it sets just enough to be firm, but still pliable. Now it's time to add the peanuts. Before being incorporated into the bars, the peanuts are roasted in industrial ovens to enhance their flavor and crunch. After roasting, they are cooled and evenly distributed over the caramel layer using precision peanut dispensers. These machines ensure that each bar receives the right amount of peanuts, maintaining uniformity across all Snickers bars. Once the peanuts are in place, the layered nougat, caramel, and peanut sheet moves to the cutting stage. High-speed rotary blades slice the continuous sheet into individual bar-sized portions. Each cut must be precise, ensuring that the caramel and nougat layers remain intact while maintaining a consistent size. The next critical step is chocolate enrobing. The milk chocolate coating used for Snickers bars is made from a blend of cocoa mass, cocoa butter, sugar, and milk powder. This mixture is refined and conched in large machines that continuously grind the chocolate to achieve a smooth texture. The chocolate is then tempered, a process that involves controlled heating and cooling to stabilize the cocoa butter crystals. Proper tempering ensures a glossy finish and prevents fat bloom, which can cause chocolate to develop a dull appearance. At the enrobing station, the cut bars pass through a waterfall of liquid milk chocolate, fully coating them. Excess chocolate is removed using controlled air jets and vibrating conveyors, ensuring an even layer without excessive buildup. Some factories use a two-stage enrobing process, where a thin base coat of chocolate is applied first to create a stable foundation before the final. Thicker chocolate layer is added. After enrobing, the bars enter a multi-zone cooling tunnel. This tunnel gradually lowers the temperature in controlled stages, allowing the chocolate to set properly without developing cracks or dull spots. Once fully cooled, the Snickers bars emerge with a perfectly solidified chocolate coating, ready for quality inspection. Quality control is a critical component of Snickers production. Each bar undergoes a series of automated inspections to ensure that it meets strict specifications. High-speed vision inspection systems equipped with high-resolution cameras scan each bar for defects such as uneven coating, improper size, or misshapen layers. Any bars that do not meet the required standards are automatically rejected and sent for reprocessing. Additional quality checks include weight verification, moisture content analysis, and sensory testing conducted by trained specialists. Once the bars have passed inspection, they move to the packaging stage. Snickers bars are individually wrapped in plastic film using high-speed horizontal flow wrapping machines. These machines use heat sealing technology to create airtight packaging that preserves freshness and prevents contamination. The wrapped bars are then grouped into multi-packs and packed into branded cartons using automated case packers. The final step in the process is palletization and distribution. Automated systems stack the packaged cartons onto pallets in precise formations, optimizing space for transport. These pallets are then shrink-wrapped for stability and loaded onto temperature-controlled trucks for distribution to retailers worldwide. Snickers bars are shipped to over 70 countries, requiring an advanced logistics network to ensure that they arrive fresh and in perfect condition. Throughout the entire production process, Mars maintains stringent food safety and sustainability practices. Each batch undergoes extensive laboratory testing, including microbiological screening, allergen testing, and texture verification. The company also invests in sustainable ingredient sourcing, reducing its environmental footprint through energy-efficient manufacturing processes and eco-friendly packaging solutions. Different Snickers manufacturing facilities may employ slight variations in processing techniques based on regional ingredient availability and consumer preferences. For example, some regions may use alternative chocolate blends with varying cocoa content, while others may modify the nougat or caramel consistency based on market demands. Additionally, special edition Snickers bars, such as Snickers almond or Snickers peanut butter, require modifications in ingredient formulation and production methods. As consumer preferences evolve, Mars continues to innovate while maintaining the classic Snickers taste and texture. Advancements in automation, AI-driven quality control, and sustainable manufacturing practices are shaping the future of Snickers production. Despite these innovations, the fundamental principles of precision, consistency, and quality remain unchanged, ensuring that every Snickers bar delivers the same delicious combination of chewy nougat, gooey caramel, crunchy peanuts, and smooth milk chocolate that has made it a favorite among chocolate lovers worldwide. The production of Tony's Chocolonely chocolate bars is a carefully designed process that emphasizes ethical sourcing, sustainability, and high-quality chocolate-making techniques. Unlike traditional chocolate brands, Tony's Chocolonely is dedicated to creating a slave-free chocolate industry, ensuring that every step in the supply chain is transparent and fair. From sourcing cocoa beans from cooperatives in West Africa to molding and packaging the final bars, the production process is a seamless blend of traditional craftsmanship and modern automation. The journey of a Tony's Chocolonely bar begins with cocoa sourcing. The company partners with cooperatives in Ghana and Côte d'Ivoire, regions that are known for cocoa production, but also face significant challenges related to child labor and unfair wages. Tony's Chocolonely implements direct trade practices, paying a premium for cocoa and providing additional support to farmers through training programs and financial resources. This ensures that the beans are ethically sourced while maintaining a high standard of quality. Once harvested, the cocoa beans go through a meticulous post-harvest process. Farmers ferment the beans for several days, a crucial step that develops the deep, complex flavors needed for premium chocolate. After fermentation, the beans are spread out under the sun to dry, reducing moisture content and preventing mold growth. When dried to the appropriate level, the beans are packed into jute sacks and shipped to Tony's Chocolonely's processing facilities. Upon arrival at the factory, the beans undergo rigorous quality control checks. Samples from each shipment are tested for moisture levels, flavor consistency, and potential contaminants. Beans that pass inspection are stored in climate-controlled silos to maintain freshness before entering the production line. The first step in the chocolate-making process is roasting. Large industrial roasting machines heat the beans at precise temperatures, usually between 120 to 150 degrees Celsius, 248 to 302 degrees Fahrenheit. This process enhances the natural chocolate flavors and eliminates unwanted bitterness. The roasting time and temperature depend on the type of chocolate being produced. Dark chocolate requires a slightly longer roasting process than milk chocolate to develop its rich, bold flavors. Once roasted, the beans enter the winnowing process. A specialized machine cracks open the roasted beans and removes the outer husks, leaving behind the valuable cocoa nibs. These nibs contain both cocoa solids and cocoa butter, the essential components of chocolate. The nibs are then ground into a thick, smooth paste known as chocolate liquor. This process, carried out by industrial grinders, reduces the particle size of the nibs, creating a velvety consistency. At this stage, different chocolate variations begin to take shape. For Tony's Chocolonely's milk chocolate bars, the chocolate liquor is combined with sugar, milk powder, and additional cocoa butter to create a creamy texture. For dark chocolate, higher cocoa percentages are used with less sugar and no milk. The next step in the process is refining. The chocolate mixture is passed through heavy-duty steel rollers that grind the ingredients into ultra-fine particles. This step is crucial for achieving the smooth texture that defines high-quality chocolate. The finer the particles, the better the melt-in-your-mouth experience. Following refining, the chocolate undergoes conching, a process that enhances both texture and flavor. Large conching machines continuously mix and aerate the chocolate for several hours, allowing any residual acidity to evaporate while intensifying the chocolate's richness. The conching time varies depending on the desired flavor profile. Longer conching results in a smoother, more developed taste. After conching, the chocolate is tempered, a precise heating and cooling process that stabilizes the cocoa butter crystals. Proper tempering ensures that Tony's Chocolonely bars have a glossy finish, a satisfying snap when broken, and a long shelf life without developing fat bloom, the white streaks that can appear on improperly tempered chocolate. Once tempered, the liquid chocolate is ready for molding. Unlike most chocolate bars, Tony's Chocolonely bars are intentionally molded in an uneven pattern, symbolizing the unequal distribution of wealth in the chocolate industry. Automated machines pour precise amounts of chocolate into these custom-designed molds, which are then gently vibrated to remove air bubbles and ensure even distribution. The molds are then transferred to a cooling tunnel, where the chocolate gradually solidifies under controlled temperatures. This process prevents the bars from developing surface defects and ensures that they retain their perfect shape. Once the chocolate has fully set, the bars are ejected from the molds and sent to the quality control station. High-speed vision inspection systems scan each bar for defects, such as air bubbles, improper molding, or uneven texture. Any bars that do not meet the required standards are removed from the production line and either reprocessed or discarded. After passing quality checks, the bars move to the packaging stage. Tony's Chocolonely uses brightly colored, easily recognizable wrappers, each featuring bold typography and branding. The packaging process is fully automated, with high-speed wrapping machines, sealing each bar in foil and paper to protect it from moisture and contamination. The wrapped bars are then packed into cartons using robotic case packers. The final step in the process is palletization and distribution. Automated robotic systems stack the packaged bars onto pallets in a precise arrangement, optimizing space for transport.